Sigelele Africa, Manu pagani su ponolayo, Yizwa imitana zoyetu, Gosi Sigelela Tina Sabolayo, Murena buluka se chavasa Yesu, ufelice tintuale la sueñe, si buluke, si chavasa, Yesu, si chavasa, South Africa, South Africa. Heidi blauw van onze hemel, uit die diepte van ons ziel. Voor ons eeuwige gebergtes, wat die krause antwoord geeft. Sounds the call to come together, and united we shall stand. Let us live and strive for freedom in South Africa.
Oh man, what a way to start an awesome session. I would like to greet you in all of our different greetings. Molo, Sawubona, Namaste, Goeiemorgen, good morning, and Assalamu alaikum wa rahmatullahi wa barakatuh to one and all. This is the Grade 10 Maths Workshop hosted by Awqaf South Africa and the Kway Institute in association with the Department of Basic Education and ISkill. We are coming to you live from the Al Falah College. The Al Falah College is also a partner to this Grade 10 Maths Workshop. We will be focusing on Maths Paper 2 today. We did do Maths Paper 1 with Algebra. So today we'll be focusing on geometry. Please do give this video a like. Do subscribe to our YouTube channel, Awqaf South Africa. In this way, you'll be informed of our future workshops. The aim of this workshop is to assist our grade 10 learners in preparation for the examination, and we will continue in the same vein during the course of 2023 to provide our learners for assistance. For more information about our workshops, log on to awqafsa.org.za and do subscribe to our social media. We will be putting that up on the screen a little bit later. My name is Hasanain Abdullah, and I'm with an organization called Awqaf South Africa, and we're involved in a series of sustainable projects to assist and rebuild our communities. Some of our projects includes boreholes, we do cricket tournaments, and this is a project that we've been involved in, the Maths Upgrade project. We've been involved in this project since 2016, and the Kway Institute has been a partner involved in this project. And at the Al Falah College, we have been hosting this project for a number of years. So today there's about 400 learners. We'll also get to see them in action. They are part of the cohort of learners that's currently at the venue. So if you are logging on via YouTube and Facebook, please do hit us up in the comments. We'd like to know from which province you are connecting to us from. Let us know the school that you are connecting to us from. If you have joined our session yesterday, Maths Paper 1, please do let us know. So now it is my pleasure to call on Mr. Kota. Mr. Kota is a driving force behind Kway Maths, and their business is assisting learners with the final examination preparation in the form of tuition. And Mr. Kota and his high energy He'll be assisting us and taking us through Maths Paper 2 today. So what we are going to do is we are going to be calling on Mr. Kota. But before we do that, we come with us on a journey as we log in the launch sequence for this rocket, the Awqaf SA Maths Workshop rocket. And let's cue that sequence in now.
Eight, seven, six, five, 3, 2.
Absolutely beautiful. Hasanain. Assalamu alaikum.
Wa alaikum salam wa rahmatullahi wa barakatuh, Mr. Kota. Are you ready for the launch? Are you ready for the takeoff today for Maths Paper 2?
Hasanain, we can't be more ready than we were. And I see your energy levels. You seem a little bit, how's your energy levels? Because we are here. We are moving on full throttle, all engines, all ignition on, all afterburners on. So yeah, welcome to everybody. Abdul Malik McPherson, Mo Lester, Limpopo, Yusuf Valley. Hey, welcome back. Good morning, Zainab Ganga, Kilo Teen 786, and welcome Limpopo, Mpumalanga, Northwest KZN, Northern Cape, Western Cape, and of course, Gauteng, Leng. Welcome everybody. I hope you guys had a bumper day yesterday, and we've got a super bumper session today. Hasanain, we all good? That's what's required today: scientific calculator, writing pad, pen ruler, and your hydration. Make sure that you have brain food. Guys, this is the program, or the proposed program, but like I said, nothing to start a day off like a fresh cup of exponents. We're going to kick off with some, we're going to finish up the exponents and exponential equations that I promised to do yesterday. Then we kick into analytics, trigs, and we end off today's session with geometry and transformation. So guys, are you all ready? I can't hear you. Are you all ready? Here we go. Hasanain, are we ready to fire off? How's the Cape Town weather on that side? And this was it. Are we
That's
doing
the
it now?
countdown. 3, 2,
1, go! Guys on the left, come on. Let it go. Come on, girls, come on, let it go. There we go. Beautiful.
another one.
Start it again. There's it going, coming right around to the front. Come on, boys. Let's go. Beautiful. I think they are wide awake now, Hasanain. Good morning.
Take it away, Mr. K.
Let's get cracking. Okay, we're starting off with exponential equations. So put the heading exponential. Thank you. Exponential equations. Now, guys, you get two types of exponential equations. One where you have one term equal to one term. What is an exponential equation? If I told you 2 to the power x is equal to 8, where x is in the power, and the question will say solve for x. So you're going to see two types in the exam. One like this, 2 to the power x is equal to 8. So you got one term equal to one term. And then you have a second type where you're going to have multiple terms. 2 to the power x plus 1 plus 2 to the power x is equal to 20. Let's say 24. So let's put a 4 there. So you're going to have one where you have one term equal to one term, or you're going to have a second scenario where you have 2 or 3 or 4 separated by a positive equal. They're done differently. They are done differently. They are done differently. So take this down. Take this down. Good morning, good morning, good morning. Our onliners, I see Orient in the house. We got, let's see who. Yes, you're ready. Good morning, Badri Alam Sheikh. Let's get cracking. Let's get cracking. Let's get cracking. So we have exponential equations. The question will say solve for x. That's type number 1. And that's type number 2. That is type number 1 and type number 2. Now let me show you how to do type number 1. And I'm going to take you from easy to difficult. We're going to do about 3 or 4. If you can do these, you can do all of them in your exam. I'll do, and maybe 1 or 2 examples of type 2. If you can identify this in the exam, you'll know exactly how to unpack it. So you all got it. Here are the rules for type number 1. Rules for type number 1. We all know we got to get them to prime basis. You got to make the left-hand side and the right-hand side basis the same. Then what do? You all know we cancel the basis. Take this down. These are the rules. Every topic in math has a set of rules. Every sport has a different set of rules. You use the right rules for the right sport. You can't go and play paddle with a soccer ball now, can you? And then we equate the powers and solve. Equate the powers and solve. Guys, you follow these 3 steps religiously. And that's the rules for scenario number 1. I'll give you the rules for scenario number 2 when we get to it. So take it down. We use prime basis. Guys, what are prime numbers? By now you all should know. 2's. Start with a 2. Numbers that have only 2 factors, 1 in itself. So we start with 2's, 3's, or 5's. Very seldom you might use a 7. Like a number 49 will be 7 squared. But most commonly will be 2's, 3's, and 5's. You start from 2 first. Okay, onliners, are we fresh? Do you have your cup of coffees? You got your morning fix? Are we good to go? Are we good to go? Are we ready? Kurtuba online in the house. Kimberley Technical. Beautiful. Western Cape, Atlanta Secondary School. Well done, well done. Welcome, 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 one and all. Guys, you do know that if you missed anything in the program, it is on YouTube on the Awqaf site. So you can re-watch these programs over and over and over again. Let's get started. I'm starting you off with the easiest one. Solve for x. Let's try. Solve for x. Now I tell you 2 to the power x is equal to 8. Come on, this is a grade 9 problem. This is not even grade 10. Let's do it together. Let's make the basis the same. So we got 2 to the power x is equal to the number 8 is 2 to the power 3. Yes or no? Right. So we made the basis the same. And we use prime basis. So that was step number 1. What was step number 2 from our rules? Cancel the basis. Very good. What was step number 3? Equate the powers. So there we go. X is equal to 3. X is equal to 3. And there we go. That's your first answer. Let's make it a little more challenging. Let's pick up the pace. That was level 1. Let's go to level 2, level 3, and level 4. Come on. Are you ready for it? Watch this. 1 over 4 to the power x is equal to 32. Let's make it even more interesting. Let's say minus 32. Watch this. Minus 32 is equal to 0. Now, guys, what do we want to do? We want to get one term equal to one term. So what's the first thing I'm going to do? Are you following me, onliners? Are you following me, on-siters? Bums on seat and eyeballs on screens. Are you following me? Good. What's the first thing we do? We take the 32 over. So what do I have? 1 over 4 to the power x minus 32 goes on the other side as plus 32. Yes or no? What base will I use? Will I use a 2, a 3, or a 5? Come on, look at the number 4. What's the first prime number that will go? Right. So watch here. 1 over. The number 4 is 2 squared to the power x is equal to the number 32. By now you should know is 2 to the power 5. Now we bring this up to the top. What happens to the power? The sign changes. So it's 2 plus 2 will come up to the top as minus 2 to the power x is equal to 2 to the power 5. I'm going to put a tick there. Do you all understand that? Right, now we need to remove the bracket. Okay, I'm asking you, can that be my final answer? Obviously not. What do I need to do? Remove the brackets. So when I raise a power to a power, what do I do to the powers? Multiply. So it's 2 to the power minus 2 times x is equal to 2 to the power 5. Now my bases are the same. Yes or no? I cancel the bases. What's left over? Negative 2x. Negative 2x is equal to how much? Can that be my final answer? I need to divide this side by negative 2. What I do on the left, I do on the... So what is x equal to? Positive divided by a negative is a negative, and I'm left with 5 over 2. And there we go. That is our final answer. Are we all following? Good. So take it down, take it down, take it down. These are ones you need to practice on. We're picking you up in pace. So you might see something like this in your exam. You might see something like this in your exam. From now, the next 3 or 4 problems are all exam style questions, June and final. And you need to know this from grade 10 to grade 12. So take this one down. Those of you who have taken that one or have taken it down already, some of you are quite sharp, you can start with the next one. 25 to the power x minus 2 is equal to 1 over 125. Right, those of you who have taken this one down, do this one. The question is worth 4 marks in your exam. I see some of you are bright sparks. Some of you are glowing on a Sunday morning with math. You can crack the next one. Solve for x in this one here on the left. Make the bases the same. Make the bases the same. Cancel the bases. Solve for x in the power. Mohammed Yasin, we are finishing all this up and then we start with paper 2, analytics. I'm just doing some exponential equations, which we haven't done yesterday. We're wrapping up this algebra and we will be starting with paper 2. Analytics, trigs, and geometry. Don't stress. By 3 o'clock, we will be done with everything. That means we would have completed the whole 6 months' work in 2 days. Well done. Kudos to you. By now, some of you should be done with this already. I'm going to do it on the side. The number 25 is 5 squared to the power x minus 2 is equal to 1 over 125. By now you should know is 5 to the power 3. I hope you all got that. Yeah, well done, well done. Well, now remember, I'm not doing rough calculation on the side. Exactly the way I answer it here is exactly the way you can answer it in your paper. Copy and paste. Now we need to remove the brackets. So we multiply this 2 by both. So it's 5 to the power 2 times x. We multiply is 2x minus 2 times 2 is equal to 5 to the plus 3 will come up to the top as 5 to the power minus 3. Yes or no? The sign of your power changes. Now what happens? My bases are the same. What do I do to the bases? What am I left with? 2x minus 4 is equal to negative 3. There we go. Simple equation now. Let's solve for x. 2x is equal to minus 3. Minus 4 will come on the other side as plus 4. Don't forget to change its sign when you're taking it over. So 2x is equal to, what is negative 3 plus 4? Can that be my final answer? It's 2 times x. What's the opposite of multiplication? And what I do on the left, I do on the, and there's your answer. X is equal to a half. X is equal to half, and that's your final answer. Right, let's pick up the pace. Let us pick up the pace. Now you're going to see a slightly different one. Now you're going to see a slightly different style in your exam. Watch here. So now we knew what to do with that. In fact, you can even have something like this. 3 to the power 3 times 9 to the power x is equal to 81. Right, now watch here. Come, I'll do this one for you. I'll do this one for you. So we got 3 to the power 1 times the number 9 is 3 squared to the power x is equal to 3 to the power 4. 81 is 3 to the power 4. So now 3 to the power 1 times 3 to the power 2 times x is 2x is equal to 3 to the power 4. Now we're multiplying and bases are the same. What do I do to the powers? Add 3 to the power 1 plus 2x is equal to 3 to the power 4. Yes or no? Now the bases, single base equal to a single base. Single base equal to a single base. What am I left with? 1 plus 2x is equal to 4. 2x is equal to 4 minus 1, which is 3. Divide by 2, divide by 2. Here's your final answer. X is equal to 3 over 2. Learn. Learn. Every example that I do with you are examinable. Learn it. I'm going to show you a different style. Take that one down on the left. Those of you who know how to do that one, I know there's some bright sparks here. We've got over 10,000 learners watching today's program. Learners, teachers, everybody. Welcome, welcome, welcome. 2x to the power minus 2 is equal to 128. For 4 marks, solve for x. Those of you who have finished this one on the left, you can start with the one on the right. Take it down. Step by step. Don't mess up with your signs. Make sure that your algebra is on point. Remember, guys, mathematics is about 3 things. SAN. S for speed. You need to work fast. A for algebra and accuracy. Speed, accuracy, and algebra. And N for neatness. I'm trying. I'm trying with my handwriting. But structure, speed and structure, accuracy and algebra, N for neatness. Your recipe for success in mathematics. Who's done with the 1 year on the left or on the right? Onliners, let's check. How many of you are done? When are you guys done? I see somebody ask here, when are we going to do paper 2? We're going to do paper 2 after we are done with this. Today is paper 2 after we are done with our exponents and exponential equation. Well done, Tabiso Tele. Yusuf Valley, you are done. Let's go. Watch here. The first thing we want to do is get rid of the 2. So we say, therefore, 2x minus 2 equals 128. I'm going to divide that side by 2. I'm going to divide that side by 2. That and that cancels out. I'm left with x to the power minus 2 is equal to 128 divided by 2 is what? 64. Now, x to the minus 2 is 1 over x to the power plus 2 is equal to 64 over 1. So I want x squared on the top. So I can flip this side, I flip that side. So watch what I do. You can do this. I want x squared on the top. So if I flip the left-hand side, I got to flip the right-hand side. Watch. So x squared over 1 will equal to 1 over 64. Yes or no? So now x squared is equal to, right. What are we going, so this here, 64, I'm going to move over to the left. I'm going to move over to the left because we need to get to x. Right. In fact, I can find the square root and I can find the square root. So x is equal to, so I'm just going to rewrite this here on the top. X squared is equal to 1 over 64. X is equal to plus or minus the square root of 1 over 64. Right? Remember, what's the opposite of square? Square root. So I find the square root on that side, I find the square root on that side. Yes or no? So x is equal to plus or minus. Square root of 1 is 1. The square root of 64. 8 eighths, 64. The answer is plus minus 1 over 8. There we go. You got it right. There is another way to do it. I'll show you now. This is method number 1. I'm going to show you another way to do it. I'm going to show you another way to do it. So the first way that we did now was to make the coefficient 1. And we worked with the power. The second way is to get rid of the power. The second way is to get rid of the power. Right, so watch what we do. Can I show you method number 2? Have you taken method number 1 down? Onliners, have you taken method number... Right, let's go another way. Wilray, let's go. Let's go. Okay, so somebody asked me to repeat this one. I'm going to go through it a little bit faster now. I'm going to redo the same problem using method number 1, and then we're going to use method number 2. Okay, watch. Let's do it all together. Let's do it together. Right. First things, let's get rid of this 2. Divide by 2, divide by 2. That and that cancels. X to the power minus 2 is equal to 128 over 2 is 64. x to the minus 2 is 1 over x squared is equal to 64 is 64 over 1. I flip this side, I flip that side. So x squared over 1 is equal to 1 over 64. Now I want to get rid of the square. So what's the opposite of square? Square root. What's the opposite of cube? Cube root. So this is the square root. So what I do on the left, I do on the... So that and that will cancel. What am I left with? X is equal to, whenever we find the square root. So what's the square root of 1? 1. What's the square root of 64? 8. So and normally when we find the square root, we put plus minus. Right, so that is method number 1. I just redid it. We now go into method number 2. Let's go now into method number 2. So let's see if we can go back there. Come on. There we go. That's erased here. Let's go into method number 2. 2 to the x minus 2. No, 2x to the power minus 2. Just call it out again for me. 2x to the power minus 2 is equal to, what's it? 128, am I right? 128. Right, let's go. Here's method number 2. Question, answer. Divide by 2, divide by 2. So x to the minus 2 is equal to 128 over 2. X to the power minus 2 is equal to 64. Right, here's the next method. How do we get rid of minus 2? We can multiply the power by minus 1 over 2. You remember you can multiply it by its reciprocal to get rid of it. Remember minus 2 times, that's over 1, times minus 1 over 2. Negative times negative is positive. 2 and 2 will cancel, we're left with 1. Remember we want the power here to be 1. So what I do on the left, I do on the right. So I multiply that one's power to the power minus half also. So watch here. So we left with x. Negative times negative is a positive. So that and that will cancel out. Is equal to the number 64 is 2 to the power 6 to the power minus a half. X is equal to 2. When we raise a power to a power, what do I do to the powers? Multiply. So it's 6 times minus a half. So x is equal to 2 to the power. 6 times minus 1, we left with minus 6 over 2. X is equal to 2 to the power minus, what is 6 divided by 2? 3. X is equal to 1 over 2 to the power 3. X is equal to 1 over, what is 2 to the power 3? 8. And there we go. We get the same answer. So you can either get rid of the power or you could have found the square root. Both methods are acceptable. Both methods, this is method number 2.
Question.
Where we get rid of the power. Well done, well done. Who likes? You says, oh yes, method number 2. Lusanda, you understand.
Question.
Let's see, what's the question? Do you have to put, yes, generally when we find the square root of a number, we generally put positive, negative, yes. Put it, it's good. Lovely, thank you. Right, let's go. Zainab enjoys number 1. Guys, you choose whichever method you would like to use. Okay. Now watch. Okay, let's move on, moving along. You all took it down. Watch the next one. Let's see. Yes. No, we put plus minus when we're finding a square root of a number. When you're finding the square root, a negative squared is positive and a positive squared is always... So when you're finding a square root, generally just put plus minus. This one here, we only get 1 over 8, but both methods for grade 10 are acceptable. All right, let's clear the frame. Let's clear the frame. Here goes the next one. Here goes the next one. Let's see. Give me a second. Give me a second. Give me a second. Right. Let's go. If I told you 3 to the power x plus 1 minus 3 to the power x minus 1 minus 24 is equal to 0. Solve for x for 5 marks. Now this one follows a different set of rules. Here, guys, what we want to do, we want to keep the unknowns on one side, we want to keep the knowns on the other side. So 3 to the power x plus 1.
Sorry. Have some water, Mr. Kauter.
Yeah. Here we go.
Take a deep breath. Woosah.
Let's go. Right. 3 to the power x plus 1 minus 3 to the power x minus 1 is equal to the minus 24 will come on the other side as positive 24. Right. So that's step number 1. Now, so step number 1 is you want to have the constant on the other side. Step number 2, we want to break it up. We want to break it all up. Divorce, talak. Step number 3, we want to take out the highest common factor. Step number 4, we want to get rid of the brackets. Step number 5, we want to solve for x. That's how we do this one. Sorry, man.
Sorry.
We're too excited to do math.
Can't we get away from the learners there? While you're getting your A, can they wave at the camera?
Let's check. Let's see. Right, the camera is pointing to our learners. Right, guys, give them a thumbs. Give South Africa a thumbs up from where you're sitting. Give them
Nice
a letter
wave there,
wave.
guys. Morning.
There we go. Here we go. Right, let's go. So step number 1, I brought it here. Step number 2, we break it all up. Watch here. Let's do it together. 3 to the x times 3 to the 1. Remember, when we multiply and bases are the same, we're going to add the power. Minus 3 to the x times 3 to the minus 1 is equal to 24. Right, put your pens down. So there we did. Step number 1, we got our constant on the one side. Step number 2, we broke it up. What is step number 3? Right, what's the highest common factor? 3 to the x. What's left over? 3 to the 1 minus 3 to the minus 1 is equal to 24. Yes or no? Right. Let's get rid of the brackets. 3 to the x into. Now 3 minus 3 to the minus 1. Here you can cheat if you want. You can use your calculator. 3 minus 3 to the power minus 1 equals. So this here in the bracket will give me 8 over 3 is equal to 24. Now pay attention. That in the brackets gives me that in the brackets. I only want 3 to the x. This is 8 over 3. How do I get rid of 8 over 3? We multiply by its reciprocal, by its opposite. So I'm going to multiply this side by 3 over 8. So the 3 and 3 can cancel. 8 and 8 can cancel. But what I do to the left, I got to do to the right. So let's see. 3 to the power x. That's what I'm left with. Let's do this on our calculator. 24 times 3 over 8. What answer do you get? 9. Can you now see? Can you now see 3 to the x is equal to the number 9 is 3 to the power 2? Yes or no? 3 and 3 cancels. What is x equal to? And you will get 5 to 6 marks for that in your exam. Learn it. Learn it. Learn this one well, guys. You're going to see this in grade 11 as well. Grade 10, 11, and 12. Okay. I'm going to show you one more scenario. So this is it. Learn this type. Whenever you see something being separated by positive or negative signs, whenever you see something being separated by a positive or negative sign, that is the rule on the side. Break it all up, take out the highest common factor, get rid of the brackets, and then solve for x. Do you guys want to do one more like this? Do you want to try one like this on your own? Right, so let's do one like this on your own to wrap up exponential equations. Let me try and think. I got a nice one for you. Watch. Shh. Let's see how sharp are you. All right, let me see. 50 bucks. 50 bucks. 50 bucks to the first person to get the next one correct. Let's go. Money time. Right. For 6 marks. Solve for x. Go for it. 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 Follow the same rules on the side. Hasanain, these guys are going to make me broke, bruh.
Make money.
Money in the group. Let's go, let's go, let's go. Right, go for it, go for it, go for it. Break it all up. Break it all up. Take out the highest common factor. Get rid of the brackets. We got an answer. They came running to the front. We got an answer. We got an answer. We got an answer. Yay! Well done. Your first name? Anusha. Surname? From Al-Falah.
But we can't see
Anusha
Anusha.
Ahmed, Al-Falah College. She gets it today. Yesterday was Overport. Marv at the back. Maybe the next round you'll get it right. Well done, well done, well done. Let's give them all a nice round of applause. Well done. Let's go, let's go. Right. So let's do it together. Let's see if you did it. Did you follow my steps religiously? Exactly the same? Let's check. Right, come on, liners. Are you ready to rock steady? Let's go. Right, let's break it all up. 2 to the power x times 2 to the power 2. That's that. Plus 2 to the x times 2 to the minus 2. Plus 2 to the x equal 42. You did that? Good. We got 3 terms. What's common? 2 to the x. So what am I left with? My first term divided by what I took out, I'm left with 2 squared, plus 2 to the x I took out, I'm left with 2 to the minus 2, plus 2 to the x divided by 2 to the x is 1. That's 1. 2 to the x divided by 2 to the x is 1 is equal to 42. So 2 to the power x into is equal to 42. Thus, if you do it on your calculator, like I said, you can cheat. Do that on your calculator, you get 21 over 4. Now, how do we get rid of 21 over 4? We multiply by 4 over 21. What I do to the left, I do to the right. So I'm left with 2 to the power x is equal to, that's over 1. 21 into 21 once, 21 into 42, 2 times 4, 8. 2 to the power x is equal to, the number 8 is 2 to the power 3, prime basis. 2 and 2 cancels. What's our answer? X is equal to 3. Well done. You did it the same way. Exactly the same way. Well done. Well done. Well done. Okay, guys. I just want to show you one more type that you might see in simplifying exponents for your exam. A very important exam question. Learn this one. You do all of them like we do the next one. I'm showing you different templates. I'm showing you different styles. So when you see this in the exam, you can recognize it. And then your pen can just flow. Right. So well done, onliners. Those of you who got it right. Well done. The next one is just simplify. We're not solving. Watch this. Watch this. Now the question says for 5 marks, simplify. Please, guys, I want you to learn this. Learn this pattern. 5 times 3 to the power x minus 4 times 3 to the power x minus 2 all over 3 to the power x minus 3 to the power x minus 1. You have seen the style before. You will see it in your June. You will see it in paper 1 in your tests in school. You will see it in your final exam. The same style. It's worth 5 marks. Well done, well done, well done, well done. Ntabi saying you got it right. Ntando got it right. Well done. Well done. Valdre Joseph, you don't understand the reciprocal. When you want to get a number to be 1, you multiply it by its opposite fraction. So if you had a number like 1 over 2, to get rid of 1 over 2, you multiply it by 2 over 1. If you had a number like 3 over 4, you multiply it by 4 over 3. Okay? Valdre Joseph, online, you multiply it by its opposite, and what you do to the one side, you do to the other side. Let's go. Let's go. Let's go. Let's go. Let's go. Right. Guys, I'm not going to... Watch here. Watch here. I'm going to give you a set of rules for this. Here's your rules on the side. Step number 1, you break it all up. Step number 2, you take out the highest common factor. Whenever you're adding or subtracting in the middle, you take out your highest common factor. Then you cancel what you took out. And then you simplify what's left over. So here we go. Let's do it together. Let's do it together. Put your pens down, follow me. Right. This is not 5 point, it's 5 times. Put your pens down. Onliners, put your pens down. Let's do it together. So let's break it all up. So it's 5 times 3 to the x minus 4 times 3 to the x times 3 to the minus 2 all over 3 to the x will stay minus 3 to the x times 3 to the minus 1. Right, so there we go, we broke it up. What's my second step? So you got 2 terms there. You got 2 terms there. What's your highest common factor? 3 to the x. So there we go. We're going to take out 3 to the x. So that's out and that's out. What's left over? 5 minus 4 times 3 to the minus 2 all over. I got two terms here. What's common? 3 to the x into 3 to the x divided by 3 to the x is how much? Any number divided by itself is how much? 1 minus. So we took that out. That would be 1. And then you're left with 3 to the minus 1. Now we cancel. Now we cancel what we took out. That and that cancels out. Now you can cheat. Go to your calculator. Say 5 minus 4 times 3 to the power minus 2 equals. My numerator gives me 41 over 9. My denominator, 1 minus 3 to the power minus 1 equals. Although they tell you without the use of a calculator, they will never know you cheated. So you can cheat legally. That's 2 over 3. Now 41 over 9. 41 over 9 divided by 2 over 3 equals 40. Your final answer is 41 over 6. They will never know you cheated. So please cheat legally. There you can use your calculator to get that. There you use your calculator to get that. Use your calculator, man. Use your calculator. They won't know you cheated. As long as you don't jump from year to year. Don't go from there to there. Don't do that. Show this middle step. Now they'll know you cheated. If you jumped from this step here down to your final answer, don't do that. Do this step and then go one more step. So you don't give them a reason to tell you, but you cheated. Okay. Guys, that brings us to the end of our algebra. Let's now go into paper 2, analytics. You guys did analytical geometry, the distance formula, the gradient formula. Yes. Right, guys. Let's go. We're starting paper 2. We are starting paper 2. Oh, you know what? Let me give you one simultaneous equation. Come on, let's do one simultaneous equation before we start with paper 2. Come on. Right. Let's go. Let's just do one simultaneous. Come on. Right, so here goes. Here goes, here goes, here goes. 2x plus 5y is equal to 20. Y equals 3x minus 5. Solve for x and y. Right. Let's solve for x and y. Let's just do one here before. Remember, simultaneous equations, the reason why I'm doing it, very important. You're going to be using it in functions. You're going to be using it in grade 11 and 12. A lot. So if you can't do simultaneous equations, you can't do math. Right. So we're going to call the one equation number 1. We're going to call the other one equation number 2. The easiest way to do it is by substitution. Right, watch. So that's equation number 1. That's equation number 2. In your final answer, I'm going to say, I already got y. I'm going to say substitute, watch, substitute equation number 2, or y equals 3x minus 5 for every y in equation number 1. So what does equation number 1 look like? 2x plus 5, y. So circle it. Y and y. So instead of y, what do I put? 3x minus 5 is equal to how much? 20. That's equation number 1. Now let's solve for x. Let's do it together. 2x plus 5 times 3 is how much? 15x minus 25 is equal to 20. 2x plus 15x, 17x. 20 plus 25, 45. Divide by 17, divide by 17. What is x equal to? 45 over 17, yes or no? Now we substitute it back into equation number 2. So we got x. Now we say substitute 45 over 17 for every x in equation number 2. So what does equation number 2 look like? Y equals 3x minus 5. Y equals 3 into 45 over 17 minus 5. Here comes the moment of truth, your final answer. There's your x. Here's your y. Cheat using your calculator. 3 into 45 over 17 minus 5. Bada bing, bada boom. 50 over 17. And there we go. You'll get 5 marks for that. How many marks? Right. So that is simultaneous equations. You start from the one equation, you substitute it in the other, you get a value, you substitute it back into. So we're moving simultaneously from one equation to another in order to finally get x and y. Do you want to try one on your own like this? All right, they want to try one more like this before we go into paper 2. Well done, Tasneem Kala. Well done, well done, well done. Well done, Tasneem. Right, let's go. Let's go. Let's go. I'm giving you one more. Let's see how sharp are you. I'm now not going to watch. Okay, let's put it. I'm going to try and make it as difficult as possible, right? I'm going to try and make it as difficult as possible. Watch. No money. Right. 2x plus 4y is equal to 20. 5x minus y is equal to 10. Solve for x and y. And come, I give you one higher order question. Watch the next one. Now, you know they always give you those higher order questions at the end of algebra. We're wrapping up algebra. We're now done. I want you to do that question. And I want you to also do, so this is question number 1. Solve for x and y. Solve for x and y. And that is worth 5 marks. Question number 2. Check the next one out. I know you're going to die when you look at it. If x equals 999, 999, 999, 999, find the value of x squared minus 4 over x plus 2 without the use of a calculator. And that one's for 3 marks. So 5 marks and 3 marks, total marks here on the screen, 8. Total marks on the screen. So we're doing simultaneous equations. We're doing simultaneous equations. So just a little bit on a lighter note, when we're talking about simultaneous equations, you guys believe that if you study maths, you will pass. You can't study math. You've got to understand math. And to show you this, watch here. Watch here. You people say if you study math, you won't fail. So that means the opposite will also apply. So if you no study will equal to fail. That's what you say. So let's call this one equation number 1. Let's call that equation number 2. Let's do it simultaneously. Let's add the two equations. So no study plus study, no study plus study on the left-hand side will equal to no fail plus fail. So I got two terms. Let's take out my highest common factor is what? Study. And what am I left with? No plus study divided by study is? On the right hand side, what's my highest common factor? And what am I left with? Plus 1. Now if I divide this side by no plus 1, what I do on the left, so we have just proved mathematically that if you study, you will fail. Right. We did simultaneous equations. We proved that if you study, you will fail. So don't study. Understand your work. Master your work. Master the processes. All right. So yeah, we just proved mathematically if you study, you will fail. So let's go back. Solve simultaneously. I'm taking a 2-minute bathroom break. Hasanain, you can keep them. Okay, 5 minutes. Hasanain, keep them busy.
Do come back, Mr. Kouter. We need you here. Don't
Yeah.
skip the country. Don't skip the country. So welcome to the grade 10 maths workshop. Mr. Kouter has just been going through a few problems from maths paper 1, but the focus of today's workshop is maths paper 2. So I'm going to take this opportunity just to share some information with regards to let's mute Mr. Kouter, with regards to a competition that we will be running. And this competition aims to award all of the grade 10 learners in your final examination. What we want you to do is we want you to submit your June examination result as well as the result that you achieve in your final examination. And this competition is open to everyone that has registered online. So kindly do register online. We will post the details. This competition is going to be open. Let's put that on the screen for you. This competition will open in January 2024. Why January 2024? This is a competition for grade 10, 11, and 12. All of these participants that have taken part in our workshop, and all communication will take place via email. So if you have registered, we'll have your details and we will be emailing you information about the workshop. So the competition, when we do open it, it's an online form. It will allow you to upload a PDF or a JPEG of your June and your final examination results. The prizes are cash prizes, and perhaps there might be a laptop or two. So it's quite exciting. Last year we had Rory Sang. He took part in the grade 12 competition. He scored about 100% in his mathematics, so he was a top prize winner. Second prize winner went to someone that scored to 99%, and the third prize winner also scored 99%. There is also a section for the most improved. One learner scored 18% in June, and because the person or the participant took part in our workshop, that person scored 85%. So we want to assess and see how these workshops are assisting you in your maths performance, your understanding, and we would love to award and celebrate academic excellence in mathematics. That's the aim of this program, the Awqaf Maths program. We want to assist as many learners as possible. So there we go. Do send us some of your photos via Facebook and Instagram. Tag us in at Awqaf SA. The hashtag is Awqaf SA Maths. Please, we want to see how you are connecting to the session, if it's in a classroom, if it's in your room, in your study, and at the kitchen table, in the lounge. Please do hit us up. Thank you for your comments. The comments have been coming in fast and steady, and we will be starting with a maths paper 2, and that will be happening shortly. So these are links for to our social media, Awqaf South Africa on Facebook. Do subscribe to the YouTube channel, Awqaf South Africa. You search Awqaf South Africa in YouTube. In this way, you won't miss out on anything in terms of our future workshops. There we go. Mr. Kote is back.
Here we go, here we go, here we go. I hope you guys got that one. Thank you so much for hasanain, for all that info. Keeping us going, keeping us going, keeping us going. Let's check. Did you guys finish those two? Did you finish those two? No. All right, so let's do it. Let's do it. Let's do this. Right, let's go. Let's go, let's go, let's go, let's go, let's go. So 2x plus 4y equals 20. Okay, let's clear that frame. So we got 2x plus 4y equals 20. And we've got 5x minus y equals 10. Now, that I'm going to call this one equation number 1. I'm going to call that one equation number 2. I'm going to start in equation number 2. So minus y is equal to 10 minus 5x. Now I'm going to divide by negative 1. So y will equal to, I'm going to divide by negative, all the signs will change. Minus 5x will become plus 5x. Plus 10 will become minus 10. We divide everything by negative 1 to get this positive. Now we're going to say, substitute 5x minus 10 for every y in equation number 1. So let's do equation number 1. 2x plus 4 into y, 5x minus 10, is equal to 20. Let's solve for x now, guys. 2x plus 4 times 5x is 20x minus 40 is equal to 20. 22x is equal to 20 plus 40, 60. Divide by 22. Divide by 22. X will equal to 2 goes into here 30 times. 2 goes into there 11 times. 30 over 11. Now we're going to say substitute 30 over 11 for every x. We were working in equation number 1. We now go back into equation number 2. And that is y equals 5x minus 10. So y equals 5 into, I got x, 30 over 11 minus 10. And our moment of truth, 5 times 30 divided by 11 minus 10 equals, you get, your final answer is 40 over 11. Do not use decimals. Leave your answers in fractions. No problem. Did you guys get that one right? Well done, well done. Give yourselves a nice round of applause. Well done. Well done, well done. I think half of them are lying, but never mind. Still, as long as you know what to do. You're going to replay this and watch it over and over and over until you master it. We're now going to do that last one, that higher order question. Now we're going to do that higher order question. If x equal 999,999,999,999, find the value of x squared minus 4 over x plus 2 without the use of a calculator. Right. Let's go. Onliners, did you guys get this one correct? Let's hear from our onliners there. Right. Let's go. Here goes. Let's clear. Check this one out. If x equal 999,999,999,999, find x squared minus 4 over x plus 2. No calculator. Right, so let's do this. 3 to 4 marks. Answer. Pay attention. That is not its simplest form. X squared minus 4 over x plus 2. That is a difference of 2 squares. X minus 2, x plus 2. All over x plus 2. Now that and that will cancel out. What am I left with? X minus 2. But what is x equal to? X is this whole thing here. So it's that whole thing minus 2. So your final answer, all we have to do here is take that and minus 2. So here's your final answer. Therefore, x equal 999,999,999. So we got that, and that. And then we got 9999. And 9 minus 2 is how much? And that's your final answer. There we go. Remember, when you're given a complex fraction, you got to simplify and you got to factorize and cancel. This was the end of year grade. This is the end of year grade 10 and and I've seen it in a grade 11 past paper 2 also. So here we go, we're done with algebra. We're starting now with analytics. We're now going to start with analytics. We got about 15 minutes. We're going to start with analytics for the next 15 minutes. We're going to go for break. We're going to come back from break. We're going to finish analytics. Then we go into trigonometry. So let's go. We're starting paper 2. Onliners, I hope you guys got that one right. So easy, Firoz Ghani. Let's go. You got this one down. It's simple. We had to just simplify that. That was the difference of 2 squares. We canceled. That's what we had. And instead of x, and we just subtracted 2. Right. Easy. Use your brain. Right. We clearing? Let's start with analytics, paper 2. We are now into paper 2. We're starting with analytics. Another word for analytics is analytical geometry. And another word for, in our days, it was called coordinate geometry because we deal with the Cartesian plane and coordinates. Then we're going to do trigs. We're going to do trigonometry. And then we're going to end up today with geometry. And then we are done. So let's start with analytics. Now, pay attention. When we're dealing with analytics, we are dealing with coordinates. So let's take that out. We are dealing with a pair of coordinates or many pairs of coordinates on a Cartesian plane. So let's draw a shape. Let's draw a shape, and that's your y-axis, that's your x-axis, and let's draw a shape. So let's say there, and there. Let's draw a triangle. I'm going to call this P, Q, R, and I'm going to put S there. S, X, and Y. Okay, so they tell you PQR lie on a Cartesian plane. Let's give you coordinates. Let's tell you that is 2 and 20. Let's tell you that is minus 10 and 4. And let's tell you R is 8 and minus 6. Now what I've done, I've deliberately chosen different values. So when we do our calculation, you don't get confused. You know exactly which values go where. Now we need to know our formulas. Guys, if you don't know your formulas, you will fail. So the first formula we need to know is the distance formula. Between 2 points, we use the distance to calculate the length of a line. We can also use it if you want to prove shapes. So we can use it for Pythagoras, we can use it to prove it to be a square or a rectangle or a rhombus or parallelogram. So what is your distance formula? Let's work out between 2 points. Let's say P and Q. So the distance between P and Q is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Right? That's called... Right. Just take the formula down. I'll ask you questions on it. We're going to do... This is an exam model. That's your first formula. You got to memorize the formulas. Although they'll give you a formula sheet, you don't want to bank on the formula sheet. You want to memorize your formulas. The second formula, very important, is the gradient formula, the slope. So we say the M of PQ is equal to y2 minus y1 over x2 minus x1. We use the gradient formula for the equation of a straight line, yes? No, you can call it, I know sometimes in school your teachers will say xp minus xq plus yp minus yq. You don't have to do it. I always use, you can call any pair of coordinates x1, y1, x2, y2. So just remember it like this, x2 minus x1, y2 minus y1. Because all shapes won't be PQR, some will be DEF, XYZ. So just remember x2 minus x1 all squared plus y2 minus y1 all squared. The same thing, I'll show you now when we apply. The gradient formula, we use it for the equation of a straight line, y equals mx plus c. So we use it to find the m. We also use it to prove collinear points. Now what is collinear? Do the points lie in a straight line? So if I told you 3 points, PQR, we need to prove that the M between PQ is equal to the M between QR. If the gradient between the first two is equal to the gradient between the second two, that means they will lie in a straight line. It means they are what we call collinear. That's the equation of a straight line. We also use the gradient for parallel lines. Very important, trigonometry. What do we know about parallel lines? The gradient of line 1 must equal to the gradient of line 2. So if you've got two lines that you are comparing, guys, pay attention. If you are comparing two lines and you want to find out if they are parallel, you calculate the gradient of the first line, you calculate the gradient of the second line. If they are the same, if they are equal, then the two lines will be right. We also use it for 90-degree or perpendicular lines. We use the gradient formula. So we had the distance formula. We got the gradient formula. For 90-degree lines, the gradient of the first line multiplied by the gradient of the second line must equal to -1. It's a rule. So if I got a line like this and I got a line like this, the gradient of this line multiplied by the gradient of this line must equal to -1 or -1. If it's equal to -1, they are perpendicular. They are 90 degrees. They can ask you, prove that the two lines are perpendicular. You calculate the gradient. You use gradient formula. The third most important one for grade 10. So we got the distance, we got the gradient. The midpoint. The next one is the midpoint. So that is formula number 1, formula number 2. Let's go into formula number 3. Please learn this. You'll see when I apply it. We're going to apply it. The third formula is the midpoint formula. X midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. Now I know this might be slightly different to what your teachers show you. They just tell you x1 plus x2 over 2, y1 plus y2 over 2. But what if the midpoint was given? Watch here. I'm going to erase the gradient now. So watch here. Watch here. I need to show you something. There's a reason I'm giving you this formula. There's a reason I am giving you that formula for midpoint. Learn this and use this. I'm going to put here use. Why? Let's say I gave you 3 points, A, B, C. Let's say A's coordinates is -4, -10. B is the midpoint. So we know that line is equal to that line. B is the midpoint, and I tell you that is 6 and 8. I want you to find C. I tell you B is the midpoint. Find the coordinates of C. Hence, we use this formula. Watch here. Let's do it together. So they tell you B is the midpoint. Right. That's X midpoint. That's Y midpoint. This is X1, that is Y1, that is X2, and that is Y2. So let's go to our formula. We're finding the coordinates of C if B is the midpoint. So X midpoint. What is X midpoint? 6 is equal to X1. What's X1? X. Plus X2. Plus, from the formula doesn't change our sign. -4 over 2. It's an equation. Y midpoint. What is Y midpoint? Is equal to Y1, which is what? Y. Right? This is C's coordinates. We're finding C's coordinates. Y. Plus Y2 -10 over 2. Now let's solve. Times 2 times 2. 6 times 2 is how much? Is equal to X -4. 8 times 2 is how much? Is equal to Y -10. Let's solve for C. 12 plus 4. 16 is equal to X. 16 plus 10. 26 is equal to Y. And here's C's coordinates. C's coordinates is 16 and 26. And you will get 5 marks for that in your exams. Take that one down. Take that one down. Learn it. We're going to use it on this diagram to find the coordinates of S. You'll see. Learn this one. X midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. Right. Then I'm going to give you one last formula before break. It's 10:24. We got 6 minutes. I'm going to give you one last formula. We're going to go for break. At 11 o'clock when you come back, I'm going to choose the same example and we're going to blast you with a whole lot of questions on it as an exam model. So we're going to take the formulas that we learned and we're going to apply it to our diagram. So we're almost there, guys. Please learn this formula. So it just depends if the midpoint is given or if the midpoint is not given. You can still use the same formula. Right, let's go, let's go, let's go, let's go, let's go, let's go. Let's go. We got one more. I'm going to teach you something new, something nice for the equation of a straight line. Watch here. I'm going to give you one more equation. So I gave you the distance. PQ is equal to the square root. I'm just recapping. I'm just refreshing your memory. X2 minus X1 all squared, the square root of X2 minus X1 all squared plus Y2 minus Y1 all squared. Then we got the gradient formula. The M of PQ is equal to Y2 minus Y1 over X2 minus X1. Then I gave you the midpoint formula. X midpoint is equal to X1 plus X2 over 2. Y midpoint is equal to Y1 plus Y2 over 2. One more formula. One more. The equation of a straight line. Watch here. The last one. Then we did, this was just an example that I showed you how to find the coordinates of C. Right, pay attention. Pay attention. This is the last formula before break. Then we're going to go for break. We're going to come back and then we're going to dala this problem here on the side. Let's go. Whenever on a straight line, say you're given one pair of coordinates, let's say 2 and 4, and you're given the gradient of the line, let's say the gradient is 6. Now they want you to find the equation of the line. I know you guys will normally go y is equal to mx plus c, am I right? Now pay attention, put down your pens. Put down your pens. I'm going to show you a shortcut. It's actually not a shortcut. You can use it till matric, till grade 12. I'm teaching you tools that you can use now, next year, and the following year. So whenever you're given one point and a gradient, to find the equation of the line, watch here. Something nice for you. Y minus y1 equals m into x minus x1. That's it. It's a new formula. All we do, we just substitute. You'll get your answer one shot. You don't have to go y is equal to mx plus c, then put the gradient, then multiply it out, then find c, then go back. It's a lot of work. So watch here, guys. Let's do it together. This is the last one before break. So let's call. There's your m. There's your m. There's your m. There's x1. There's y1. Let's do it together. Y minus 4 is equal to m is how much? Into x minus 2. And there we go. We just multiply out our brackets and we got y is equal to mx plus c. Y minus 4 is equal to 6x minus 12. Here's your final answer. Y equals 6x minus 12 plus 4. Bada bing, bada boom. Done. It saves you half the time. It saves you half the time. Now, normally they'll introduce you this in grade 11 or 12. Why? Do it now. Do it now. Use it from now. Nothing stops you. Okay, and that's 10:29. Yes, as we're moving on perfect time. We are moving on perfect time. This is taking us to break. We will regroup at 11 o'clock. You got a 30-minute comfort bathroom break. Please, guys, if you are aiming in the toilet, make sure you aim straight. Keep the toilets clean. Enjoy your break. Hope you guys enjoyed the first session. Hasanain, you can take it away during our break.
Thank you so much. We'll give Mr. Kota an opportunity to raise his vocal cords. Yes, we have started with grade 10, Maths Paper 2. Thank you for the code of 400 learners that's currently situated or currently at the venue at the Alfala College. About 400 of these participants. They have been awesome. We've been doing Mexican waves. We've been learning the fun way. And yes, we will resume shortly. We're currently having a break and we're doing Maths Paper 2. So we'll see you after the break. Don't forget to subscribe to our YouTube channel. That is Awqaf South Africa on YouTube. Subscribe to the channel. We will be having more programs during the course of the year to prepare you for your maths examination. So if you do subscribe to the channel, you won't miss out. It is our intention to host workshops as preparation for your final examination. We have been conducting these maths workshops across South Africa, and we have also been focused on workshops for this is the grade 10 workshop. We have also hosted, I think in the beginning of May, we have hosted grade 11 workshops as well as grade 12 workshops. Also, look out for our competition. Just to inform you, let's get that on the screen. So we'll be hosting a competition for grade 10, 11, and 12. Everyone that has took part in this workshop, what is required is that you should have registered online. So if you have not, just hurry on over to awqafsa.org.za. You may register, and all communication about the competition will be communicated via email. And by January 2024, we will open up the competition. Why January 2024? This competition caters for grade 10, 11, and 12. Grade 12 learners normally get the examination results, the final results in the new year, January 2024. So we will send that email out, and it's as simple as posting your June and your final examination results on our easy to fill out online form. So look out for that communication. So if you do subscribe to us via Facebook, Twitter, and YouTube, we will be posting little daily posts or posts leading up to the build up to that competition. So we will take a break and we'll be back shortly.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care. Quality education is a cornerstone of a thriving and prosperous society. However, the South African educational system is under strain, necessitating the work of the Educational Waqf Fund to help ease the pressure. Our matric mathematics upgrade project alone has already impacted the lives of over 40,000 matriculants. At the schools participating in our program, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience.
So I've never reached that kind of height before. It was quite a milestone, and I believe that Awqaf has been quite instrumental in me reaching that milestone. And I also liked the spirit. Mr. Kota made sure that we're always engaged with the content. So for me, that's what made it a very positive.
With the very first word of the Holy Quran being revealed as read, educating our community is an act of faith. With your help, we can transform many more lives.
Welcome back to the Grade 10 Maths Workshop. This is the Grade 10 Maths Workshop, and we're focused on Maths Paper 2. We'll be going through geometry and the like, and we're about to start now. So we'll call Mr. Kota. I'm sure that he's refreshed and he's ready to go with the session. Mr. Kota, we need to unmute you.
Welcome back, onliners and on-siters, bums on seat and eyeballs on screen. We just give it a couple of seconds for the learners to settle down and come in, hasanain. We'll give it another minute or so for everybody else to come in.
Tell me,
And
Mr.
we will
Kota.
get started. Give
So
me a second.
we're beaming from Awqaf SA's studio is here in Cape Town. It is freezing. The temperature was about 6 degrees this morning. Mr. Kota, you in KwaZulu Natal? Tell us about the weather and how things going at Al Falah College.
Absolutely amazing. Beautiful KZN, Overport and Umhlanga. Can't beat it. Absolutely amazing. Weather is beautiful. People are beautiful. School is welcoming. Learners are amazing. What more can we ask for? What more can we ask for?
Fantastic, man. You're going to catch some waves today, Mr. Kota.
Definitely. When I'm finished with the program, we're just waiting for the learners to come in, guys. Let's give it another about a minute or so. And yeah, when we're done with the program today, I'm heading straight off to the beach. I need to go and lay on the beach and soak in some KZN sun. Lepaka Songelwa, welcome back. Yuri, welcome back. Welcome back, Giddy Giddy. Welcome, everybody. Good morning, Jordan. Good morning, good morning, good morning. Our onliners from across the country. Okay, guys. Let's get started. We did exponents, exponential equations in the first session with some formula for analytics, paper 2. We then went for break. And like we always say, if you missed anything, you can go onto the Awqaf YouTube live. It's being live streamed there and recorded. So you can play these sessions over and over and over until you have mastered the content. There's the Facebook handles coming up. Instagram at Awqaf SA, Twitter, YouTube, Awqaf South Africa. Just type in on YouTube, Awqaf. Boom, you'll be in. Right, hope you guys enjoyed your break. Let's get cracking. This is where we stop before break. Welcome back, onliners and on-siters. We've got about 400 learners here from all across KZN. Let's get cracking. Okay, guys, grade 10s, let's get started. So the first question here, question number 1, they want the gradient of PR. Find the gradient of PR. We're doing application. Any of you missed the application, the formulas? It was in the session 1 of today, before break. You can go back and you can replay it this evening. So they want the gradient of PR for 3 marks. Question number 2, they want the equation of PR for another 3 marks. Question number 3, is PQ perpendicular to PR? Show all calculations. Is PQ perpendicular 90 degrees to PR? Show all calculations. And that's worth 4 marks. Number 4, find the coordinates of S. Find the coordinates of S, X, and Y. If PQRS is a rhombus for 4 marks. Give me an equation of a line. Take this one down, onliners and on-siters. Equation of a line parallel to PQ parallel to PQ passing through R. Passing through, right, let's go back. Point R, and that is for 6 marks. Total marks here, 6 and 4, 10, and 4, 14, and 6, 20 marks here, guys. 20 marks on the take, for the take, paper 2, analytics. Now, if you haven't done it before, then pay attention. I've given you the formulas before break. We're going to be applying the formulas and answering all the questions in red here at the bottom. So the answer to question number 1, let's all do it together. So I'm going to give you a couple of seconds to take the diagram down. There's S, X, and Y. Here are your questions. 1, 2, 3, 4, 5 questions worth 20 marks. This is paper 2, analytics. Right, come through grade 10s, hurry up. Settle down, and we need silence here in the hall. Let's get cracking. Let's go, let's go, let's go. Let's check how's our onliners doing. Onliners, are you guys ready? Bayanda, are you ready? Lapoka, are you ready? Let's get going. Thank you, Simpiwe. Nice to have you back with us, sir. Let's go, let's go, let's go. Right, settle down. Grade 10, settle down. Okay, let's answer the first question. They ask you for the gradient of PR. So we're looking at P, not PQ now. We are not looking at PQ. That's Q. That's point Q. That's point P. That's point R. They are looking for the gradient of PR. So how do we answer it? We say the MPR. The gradient of PR is y2 minus y1 over x2 minus x1. Now, the gentleman right here in the front who asked me earlier on, we can call any one x1, y1, x2, y2. So let's do this. Which one do you want to call? Let's call this one x2, y2. Let's call that one x1, y1. We never use x3, y3. We always only working with 2 coordinates at a time. So anyone, if you wanted to call this one x1, y1 and this one x2, y2, no problem. You'll get the same answer. All right, so watch. Let's do it together. Follow. y2 minus, now pay attention, minus y1 minus minus 6. The first negative comes from your formula. Minus minus 6 plus 6 over x2 minus x1 minus 8. That will give me 20 plus 6 is 26 over negative 6. Positive divided by negative is negative. 2 goes into there 13 times. 2 goes into there 3 times. And there's your answer. The M of this line. Now you go back to your diagram and you say minus 13 over 3. The minute you get an answer, go back to your diagram, put it on there because you're going to be using it later on. That was very easy. Straightforward plug and play. Substitution. We got our first 3 marks. Total marks, guys, 20. So we're going to get 20 out of 20. We want to score full marks in this. Total marks for this question, 20 marks. We got our first 3 marks. There we go. You get a mark for the formula. You get a mark for substitution. You get a mark for your final answer. So take it down. Take it down. Let's see, how's our onliners? Welcome, welcome, welcome to those of you that have just joined us. You missed a bumper session yesterday, paper 1. We did a lot of work, the whole of algebra, and we did the whole of functions. This morning we finished off exponential equations, some higher order questions, and now into paper 2 with analytics. So welcome everybody online and on site. Let's go, let's go, let's go. Let's answer question number 2. Guys, let's answer. This is question number 1. Let's go on to question number 2. Right, I'm erasing that. We're answering question number 2. The answer to question number 2. The equation, read your question carefully. If they ask you for gradient, you give the gradient. If they ask you for equation of PR. So what do I need? I need a point and I need the gradient. So I'm going to use R's coordinates, 8 and minus 6. And I've got the gradient minus 13 over 3. So now I'm going to use that shortcut that I showed you before break. Y minus y1 equals m into x minus x1. Can you see how we apply it? Now watch. Y minus minus 6 plus 6 is equal to m minus 13 over 3 into x minus 8. Let's multiply this out and let's get it in the form y equals mx plus c. Y plus 6 is equal to minus 13 over 3x plus 13 times 8 divided by 3. 13 times 8 divided by 3 gives me 104 over 3. And now I take the 6 on the other side to become minus 6. Here's your final answer coming up. Y equals minus 13 over 3x. 104 over 3 minus 6. 86 over 3. And that is the equation of PR. Y equals minus 13 over 3x plus 86 over 3. And there we go. We answered the second question. We got our next 3 marks. Learn. You're going to use this till grade 12. This is from grade 10 right up to grade 12. Master this. Right, those of you who want to start question number 3, you're welcome to start number 3 already. Is PQ perpendicular? The minute they use the word perpendicular, you know that formula. The m of line 1 times the m of line 2 must equal to minus 1. So calculate the 2. Calculate the m of PQ. Calculate the m of PR. We got the m of PR. We got the m of PR. We need the m of PQ. Shh. Take this down. Onliners, I hope you're working. It's a Sunday and we are cracking maths before the June exams. 86 over 3, guillotine, that's 104 over 3. The plus 6 comes on the other side as minus 6. Now these two on a calculator gives me 86 over 3. I hope that answers your question, guillotine 786. I see your comments popping up there on the side. I can't answer every question, but I can try and answer the questions as they come up. Pleasure. Let's go. Let's go, let's go, let's go. The rest of you do number 3 already. We're answering question number 3 now. We are answering question number 3. Let's go, let's go, let's go, let's go. Let's answer question number 3. So we're done with question number 1. We're done with question number 2. We're busy with question number 3. PR. the m of PR is equal to, we calculated it, minus negative 13 over 3. The m of PQ is equal to y2 minus y1 over x2 minus x1. PQ, y2 minus y1 over x2 minus x1. Minus 10 plus 10. Work that one out. Work that one out. Leave that as a fraction. We don't work with decimals. Leave it as a fraction. This is equal to 20 minus 4 is 16. Over 2 plus 10 is 12. 4 goes into there 4 times. 4 goes into there 3 times. Therefore, the m of PR multiplied by the m of PQ is equal to minus 13 over 3 multiplied by 4 over 3, which is not equal to negative 1. Therefore, PQ is not 90 degrees or perpendicular to PR. Remember, for it to be perpendicular, they had to, the product of the gradients must equal to negative 1. The product of the two gradients must equal to negative 1. So they're asking you, is it? So you had to prove it. You can't assume it. Again, I see you guys understood it. You've got it already. Do number 4. Start number 4 already. If S, X, and Y, there we go. Find the coordinates of S, X, and Y if PQRS is a rhombus. So PQRS, they tell you it's a rhombus. What do they tell you? What shape is it? And what is a rhombus? What is a rhombus? It's a tilted square. It's a tilted square. So it's a square that just fell on its side. So the only difference between a rhombus and a square is a square meets at 90 degrees. But all other properties apply. So watch. Let's do, I'm doing question number 4. I am now doing question number 4. I'm now doing question number 4. Now pay attention. Whenever you see this scenario, this is what I want you to do in the exam. I want you to join the dots there and join those dots there. Why? Because it's got a common midpoint. That piece is equal to that piece, and that piece is equal to that piece. That means it's got a common midpoint. So that is M. That point there is M, the midpoint. So we're going to use our midpoint to answer question number 4. So watch here. The same midpoint of PR is the same midpoint of QS. So let's do it. The midpoint of PR, X midpoint is equal to X1 plus X2 over 2. Y midpoint is equal to Y1 plus Y2 over 2. X midpoint, we're looking for it. X1, so we're doing PR, guys. We are doing PR. What are we doing? PR. So let's go. Let's do it together. Let's substitute. X1 plus X2. You can, anyone, X1, X2. All right, so let's go here. X1 plus X2. 8 plus 2 over 2. Y midpoint is equal to y1 plus y2 over 2. 8 plus 2 is 10 over 2 is 5. Minus 6 plus 2 is 14. 14 over 2 is 7. That means this point here is 5 and 7. My midpoint is 5 and 7. The midpoint of PR, there we go. The midpoint of PR is 5 and 7. But we're not yet done. We need to get to S. We are not done. We now need to get to S. Okay. Hasanain, your mic is on at the back.
Sorry.
No problem.
We're just getting ready for load shedding here. I had to get some petrol for my generator. So my apologies.
No stress, no stress, no stress. We carry on. 5 and 7. Right. Now we need to get to S. It's the same midpoint. It's the same midpoint. So watch. This was part 1. We're now going to do we're going down to part 2. We're going on to part 2. So 5 and 7 we got. I'm just erasing here because I don't have space. Right, here goes. So now, to get S, x midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 all over 2. X midpoint, 5, is equal to x1, which is x, plus x2, which is 10. I'm now using QS. Guys, I'm now using QS over 2. Y midpoint is equal to y1 plus y2 over 2. We now need to solve for S, x and y. 5 times 2 is 10. 5 times 2 is 10. Plus 10 equal x. 7 times 2 is 14. Plus 4 will come on the other side as minus 4 is equal to y. So S's coordinates, you're going to get full marks now. 10 plus 10 is 20. 14 minus 4 is 10. And here's your final answer, 20 and 10. 20 and 10. We don't think we're right, we know we're right. Agreed? Good. This is part 2. So this problem here, question number 4 was done in 2 parts. Part 1 and part 2. Both using the midpoint formula. Both using the midpoint formula. Let's see who's sharp. Let's see who can get the last one right. By now you got 14 out of 20. Let's see who can get 20 out of 20 by getting the last one for 6 marks correct. No money. Right now here there's some serious calculation. There's some serious calculation here. There is some serious calculation because we need the gradient and we need a point to get the equation. Remember, equation is y is equal to mx plus c. The equation is y equals mx plus c. And they talk about parallel lines, and they talk about point R, and they talk about line PQ. Very important pieces of information. I'm sure you've taken this one down. You can't be wasting time today. Come. Right. Okay. They want an equation of a line parallel to PQ passing through R. This is the way. This is where the line would be. They're coming down here. So they want that. That's what they're looking for. That line parallel to that line. So that means the gradient of this line must equal to the gradient of that line. And we got a point. So we're very good. We just need the gradient of QP. Didn't we find the gradient of PQ in question number 3? What was the gradient of PQ, guys? Was it 4/3? So this is the way we're going to answer it. We're answering question number 5. We are answering question number 5. Right, PQ. So the M of PQ was equal to 4/3. That we got from question number 3. Therefore, the M of the new line is also equal to 4/3. Why? Because they are parallel. The M of line 1 must equal to the M of line 2. You must put in your reason. So now we got the gradient of this new line. Pay attention. We've got the gradient. The gradient of that was 4/3. Therefore, the M of this line is also equal to 4/3. And we got a point on the line. So we got gradient and point. Therefore, the equation of the line is y minus y1 equals m into x minus x1. So y, we're now using the point R, 8 and -6. We're using the point R, 8 and -6. So y minus -6, y plus 6 is equal to 4/3 into x minus 8. Y plus 6 is equal to 4/3x minus 8 times 4 is 32/3. Here's your final answer coming up. Y equals 4/3x minus 32/3 minus 6. 50/3. And that is your final answer. And there we go. That brings us to the end of analytics, and you've got yourself 20 marks. Now, the only thing that will happen in your exam, they'll change the diagram, but they'll ask you the same questions. Calculate the gradient, calculate the... Oh, they can ask you one more question. Calculate the length of QR. Come on. Calculate the length of QR. Let's do that one. Let's wrap this one up. Calculate the length. They can even ask you what type of a triangle is PQR. Then you'll just calculate the 3 distances. If all 3 are the same, it's equilateral. If 2 distances are the same, isosceles. Very good. If all 3 distances are different, scalene. Right. I want the distance of QR. I want you to calculate the distance of QR. Work that one out on your own. That will bring us to the end of analytics. That's it. Know your distance. Know your gradient. Know your distance. Know your gradient. Know the equation of a line. Know parallel lines and perpendicular lines. Know your midpoint. I want the length Question number 6, the last one, I'm adding a question on. Question number 6. I want the length of QR for 3 marks. Right, so here goes. QR is equal to the square root x2 minus x1 all squared plus y2 minus y1 all squared. So QR is equal to x2 minus x1 minus 10 minus 8 squared plus y2 minus y1 minus 6 is plus 6 all squared. So QR is equal to the square root. In fact, now what you can do from here, just go straight into your calculators. Go straight into your calculators, put there the square root, open brackets, minus 10 minus 8 squared, plus 4 plus 6 is 10 squared, which is 100. 2 root 106. 2 times the square root of 106 units. Do not use decimals in analytics, not at all. Please, in the entire topic of analytics, do not use decimals. In the entire topic of analytics, I want you to remember this. In analytics, we never use decimals. We only use fractions. Wink, wink, nudge, nudge. Okay, and that brings us to the end of analytics. Finished. The topic is done for the year. That's it. Distance formula, gradient formula, equation of a straight line, parallel lines, perpendicular lines, collinear points. Finish. Right, that brings us to the end for the whole year. For the whole year. For the whole year. You ready to write your final exams? Now listen quickly, listen. Many of you, just to wrap this up, many of you don't know what your quadrilaterals look like. Let me just do it for you quickly because we're going to be using this in geometry later. Right. Properties. Properties of quads. Quiet. Okay. You guys know a square, you guys know a rectangle and a parallelogram. But, okay, so we got this one here, which is a tilted square, which we just did in the one above. And what is that, this shape called? A rhombus. So that is equal to that, is equal to that, is equal to that. That side is parallel, and then this side is parallel. So these two gradients will be the same. Those two gradients will be the same, and the diagonals bisect each other. Right, that's a rhombus. The next one is a trapezium, a trap. Trapezium, it's a trap. Don't do it, it's a trap. There we go. There's the trapezium. And the main thing there is only one pair of opposite sides are parallel. So the M of this line will equal to the M of that line. That's all. Nothing else. Nothing else. So you got a rhombus, you got a trapezium. And remember, this is a parallelogram. It's a palm. It's a parallelogram. Okay. Now the last one. The last one that you need to know is a kite. Quiet. So here goes. What are the properties of a kite? Yes, the adjacent sides are equal. The adjacent sides are equal. The diagonals all meet at 90 degrees. Very important. Diagonals meet at 90 degrees. And one more. The long side bisects the short side into two equal parts. So this piece here is equal to that piece there. The long side, that's that long side, bisects this. So this is equal. Midpoint, that's a midpoint. The long side bisects, or the longer diagonal, the longer diagonal bisects the shorter diagonal. So let's not say side, let's say diagonal. The long diagonal bisects the shorter diagonal. What does the word bisects mean? Into two equal parts. And there we go. So that's your kite. Kite, trapezium, rhombus. You need to know this for analytics, and you need to know it for geometry when we get to geometry later.
Question.
Right, let's hear. Angle of inclination, you guys don't do it in grade 10. Angle of inclination is only grade 11. Or have you guys done it? No, you haven't done it in grade 10. They only do it in grade 11. Angle of inclination is introduced in grade 11. Tasneem, they only do it in grade 11. Some schools might introduce it to you now.
Mr. Kauta, can we get a holler back from the learners there? Can we wave? Can we feel the energy at Alpha
Alright,
La?
guys, just give everybody a big wave there from the back.
Hello.
Let's check. There we go.
Tell us you are live. Proof of life. Proof of life.
Okay. Don't worry, Theogani, Kelly. Don't worry about angle of inclination. It's not part of your grade 10 syllabus. But some schools introduce it at grade 10. Don't worry about it. Okay, which school are you, Tasneem? Yes, Tasneem, which school are you? I know Nizamia does it. I know some schools will do it. Are you at Nizamia? The Turkish schools. I know Turkish schools, they already introduced the grade 10s to grade 11 work. Which school are you, Tasneem?
She'll give us a
Hit us up in the
response.
comments. Okay, that brings us to the end of analytics. Quiet. Star College. Okay. But isn't Star College also a Turkish academy? Yes, I told you. I'm sharp, right? One thing, I'm sharp, right? Okay, the Turkish. Yeah, I know the Turkish schools. They bring it in. In fact, you guys would have already been completing the square and all the grade 11 content already. So, Tasneem, what I'd like you to do, Tasneem, I'd like you to watch our grade 11 program on Awqaf. It's also on the YouTube website. If you are at the Turkish school, if you are at any Turkish school in South Africa for grade 10, you need to master the grade 11 syllabus also. And next year, Tasneem, grade 11, you would need to master the grade 12 syllabus because they finished the grade 12 syllabus in grade 11 also. Okay, let's go. Thank you, hasanain. There's the link. Tasneem. You can just click on it and join. You can re-watch the grade 11 workshop that we did for angle of inclination. Right, ladies, girls, thank you. Right, now comes the big topic, the one that you guys are very afraid of. Trigonometry. All right. I'm just clearing the frame. I'm waiting for the frame to clear here. Looks like Google has got a bit of a slight delay. There we go. What is the time now? 11:42. Right, now pay attention. Right. Many of you, let me see show of hands. How many of you have done trigonometry at school? Trigs. Oh, wow. Everybody has done trigs. So let's go, everybody. Okay. Now, listen, grade 10s, I need silence.
Question.
Grade 10s, I need absolute silence. This is a very important topic. I'll wait for you to be silent. I will wait for you to be silent. Thank you. Right. This topic is required for grade 10, 11, and 12. It goes up to 40 marks, 40 out of 100 or 150 next year. A third of your paper 2. Now, many of you don't know what's going on, but if you listen to me today, forget about everything. If you were confused, forget about what you know about trigs. You pay attention to what I'm about to teach you now. We're going to sort trigs out completely. I'm going to start trigonometry from you, assuming that you know absolutely nothing. Now listen, you need to pay attention because it's a story. It's as if you are on a tour going to Cape Town and you're in the tour bus and I'm the tour guide. And I'm going to show you what the topic is about. But if you don't pay attention and if you sleep, whether you are online or on-site, the problem is yours, not mine. I will show it to you. But you need to follow the story. Because once you understand the story, you will understand the whole picture. And this goes for onliners as well. So I want absolute attention. I want you guys focus on the screen 100%. Do I get a thumbs up from my onliners? Are you willing to pay attention absolutely and forget about everything else? Let's go. Thank you, Safia. Thank you, Guillotine. Right. Learners, do I get a thumbs up here from you? Onliners? On-siters? Sharp. Let's go. Pay attention now. Pay attention. Now forget about trigonometry. I'm going to teach you something. I'm giving you from the introduction. We're starting a story. Remember, for grade 10, we are only going to be dealing with 90-degree triangles. Now do not write. I'm putting you in the picture of trigonometry. Now the word trigonometry. Right. Onometry or metry means the study of. And tri means triangles. So all we're going to be doing for grade 10 is that we are going to be studying 90-degree triangles. Now if you understand that, we're on a good wicket. I'm not yet done. You need to pay attention. Now you know in a 90-degree triangle, that's what we're going to be dealing with. If I gave you this as 5 and I gave you that as 20 degrees, and this is triangle ABC, and I say find AC, with the knowledge that you currently have, forget about trigonometry. Assume you never saw trigonometry before in your life. With the knowledge that you currently have, can you find AC? No, you can't. Why? You got two unknowns. You got AC as an unknown. You got BC as an unknown. Yeah, if you were given this as 6 and that as 5, no problem. We can use Pythag. No problem. We're going to be using Pythagoras a lot because we're dealing with 90-degree triangles. But I didn't give you this. And I didn't give you that. So again, I'm asking you the same question. With the knowledge that you currently have, can you find AC? No. Hence the need for trigonometry. Because trigonometry helps you to find sides from angles or angles from sides to solve 90-degree triangles. For now, it's 90 degree. Grade 11, you'll do non-90. Don't worry about grade 11. For the whole of grade 10, we're only dealing with 90-degree triangles. So we want to solve. What does it mean to solve? To find the unknown angles and to find the unknown sides. Yes or no? But again, I'm telling you, with the knowledge that you currently have, you cannot solve a side with angles and you can't find angles with sides. You can't. Hence the need for trigonometry. Okay? Onliners, are you with me? Are you following? Are you following? Give me a thumbs up so I know you are paying attention. Right. Now relax. Relax. We are still on a journey. I need to make you understand this because if you understand this now, you'll understand it till grade 12. Thank you. Now, forget about this. So we've understood. We've understood. We're dealing with 90-degree triangles and trigonometry helps us to find sides with angles or angles with sides. Now pay attention. So I give you a triangle. Pay attention. Ooh, I got 50,000 people absolutely glued to the screen. All eyes on me. Triangle PQR. Listen. This angle R, we call it angle theta. We don't call it X and Y. In trigonometry, in trigs, the unknown angle is called theta. Theta. It's a Greek letter, just for an unknown angle. So you never use theta, alpha, beta for algebra like X, Y, Z or ABC. Then we got alpha. That's the sign alpha. And that's the sign beta. It refers to unknown angles. Pay attention. So this is angle for now. And in this case here, this is angle theta. They've told you that's angle theta. Unknown angle. And that unknown angle there is what we call a reference angle. Why? We are referring to this angle with reference to that angle. So whenever I say what is our reference angle, that is called our reference angle. If I call that angle beta and I start talking about beta, then that would be my reference angle. But in this case, we only got angle theta there at the bottom. Right, now pay attention to me and pay attention carefully. Right. If this is my reference angle, the side opposite it is called my opposite. The side opposite your 90 degrees is what we call, we all know, hypotenuse. Very important, guys. If you do not know this, you can't do trigonometry. The first thing you do when you get a triangle is you put O for opposite, H for hypotenuse, and what is the last side called? Adjacent. The last side is called. So we're only dealing with three sides, O, A, and H. O for opposite. Opposite what? Opposite your reference angle. H for hypotenuse, which is the side opposite what? Opposite your 90 degrees, am I right? And then your remaining side is called your adjacent. So OAH, and because we have these three alphabets, we now are introduced to the three Greek trig ratios: sine, cos, and tan. Now listen, I'm now introducing you, I'm taking you into a journey now. Sine, so now, you write, oh hell, another hour of algebra. Sine, cos, and tan. Sokatoa. Sokatoa. We now introduce to our Greek acronym Sokatoa. So sine is our opposite over hypotenuse. That side over that side. Cos of theta, of our reference angle. Cos is adjacent over hypotenuse. And tan of theta is our opposite over adjacent. So take this down. This is important. I'll give you a minute or two to take all this down. Then we're going to start. I'm going to show you how to solve triangles. Then I'm going to introduce you to the Cartesian plane. Then we're going to find angles and find sides using Pythagoras. Follow my train of thought. How are we doing onliners? How are we doing onliners? Alhamdulillah, I'm getting thumbs up from everybody. Well done. That boy, Asonge, Selisizwe, Ionella Douglas, well done. I'm getting a thumbs up. Safia Gul following. Nabil Makada or Magda. What's it, Makada or Magda? Zayana Rahim, Moses Rida, you got this, bro. Kilodin 786, well done, well done, well done. I'm so glad. Adeline, Lapaka. That boy, Lusanda Butalezi. But Rialam Sheikh, well done, my bro. Fortnite victory. Good vibes, good vibes. Take this down. Mawande, doing great. Thumbs up, Mawande. Raisu. Take this down, take this down. Wow, I think we've got 20,000 online learners who are completely engaged and our 500 or 400 learners here. So well done and kudos to all of you. Now we're going to start. Now we start solving. Right. Have you taken it down? Do you need another 20 seconds? Hurry up. So theta, alpha, beta refers to our reference unknown angles. SOHCAHTOA is our acronym to remember. That sine is our opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. And I am hoping that the explanation I'm giving you towards this introduction to trigonometry is one of the best introductions to trigs that you've received. I want you to understand it, see the picture, then we play with the numbers. Many of you are going to walk out mathematicians today already. You've never done so much maths in 2 days in your life. Welcome to Kway. We're going to have another one like this before September. We're going to have another one like this before your final exams. Then I take out past papers. Whatever I taught you, we only apply, and we finish a 3-hour paper or 2-hour paper in 1 hour, sometimes 45 minutes. We finish your whole exam. But you got to know your work. You got to know your work. That's my job, to teach it to you first. Then we apply. Let's go. I'm clearing the frame. Let's go. Here goes. Shh. Pay attention. Pay attention. Okay. Watch here. They give you that. They give you that. They give you this. They tell you that is point P minus 3 and 5. They tell you this angle is angle theta. That's 0, that's y, that's x. Right. Question number 1. Find sine theta. Question number 2. Find cos theta. Question number 3. Find tan theta. Question number 4. Find theta. Question number 5. Find 2 sine theta over tan theta without the use of a calculator. This last one, no calculator. The last one, no calculator. Shh. 2 marks here, 2 marks there, 2 marks there, 3 marks there, 4 marks there. Total marks. 2, 4, 6, and 4 is 10, and 3. 13 marks. This is the opening question. This is the opening question for trigonometry, paper 2 in your exam. Now pay attention. Shh. Let's do it together. Let's do it together. Put your pens down. Many of you don't know where to even begin. Many of you don't even know.
1, 2.
There we
Can
go.
you hear me,
There
Mr. Kota?
I can hear you clearly, sir.
No, we're on
Are you
backup
back
power.
in? Right, here we go. Here we go. Imagine, Bon here says, please re-explain. I had to do something. What a joke. I must re-explain because you had something to do. You funny, ne? I think we funny here. Woo, load shedding. Are we coming back on or gone off?
So we're together in this, Mr. Kota? So there we go. So we'll just give Mr. Kota a few moments. I think they are currently load shedding at the venue. From the Awqaf SA Cape Town studio, we're also load shedding at the moment, and we are on backup power. So we'll just give Mr. Kota a few moments just to resume that the backup power does come on. Please bear in mind, if you are experiencing any problems in terms of load shedding, you can refer back to these videos and these sessions. These sessions are hosted on Awqaf's YouTube platform. The videos will never ever be removed. All that you need to do is log on to the Awqaf SA webpage, and we do have an event page for our maths workshop, and you can view that session. Let's put that link up for you at the moment, just as a reference.
I can have a little bit of a stretch as well.
There we go. That's that link, awqafsa.org.za. There is a Awqaf SA maths workshop. There is a maths workshop event page. And on this page, all of the videos of today's sessions, as well as some of our other grade workshops, the videos are available on YouTube. So I'm just going to share some information. So we are involved in the grade 10 maths paper 2. So we will be going all the way to 3 o'clock. We will have some comfort breaks as well. This is the details that you need. This is the, let's hide that comment. So these are details of Awqaf's social media, the most important one being the Awqaf SA YouTube channel. You can search Awqaf South Africa, and with that, this will take you to Awqaf's YouTube platform. These videos are hosted on Awqaf's YouTube platform primarily, as well as Awqaf's Facebook page. Also send us some photos, tag us in your social media status updates. You can do that later on after the session. We are Awqaf SA on Instagram. Tag us in on your TikTok posts. If you do tweet, we are Awqaf SA on Twitter as well. So there we go. We're just having a little bit of a break. Mr. Kota and the venue, we are waiting for backup power to resume. And on our side here in Cape Town also, we are in on backup power. This is just some of the realities of the session. But do not fear, we will be up shortly.
Hello there, my name is Sororisa Makaila. I am in my first year of my undergraduate studies in actuarial science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Awqaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Awqaf SA has been greatly instrumental in me reaching my goals in matric. I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Awqaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Awqaf SA and good luck on your examinations.
Here we go. That was a message from Rory-san. He participated in our workshop last year. He did quite well. He actually achieved 100% in mathematics. So that's an inspiring note for you. We're just waiting for Mr. Kota. He will be coming on now. I think the power is back up. He's just catching a refreshment just to keep himself hydrated. It's a very demanding role from Mr. Kota to keep going for 6 hours. So there we go. It's very important for you as grade 10 learners to do very well in mathematics. The future careers going forward would require you to be performing or require mathematics if you decide to pursue a study at university. So there we go. Mr. Kota is back. The man, the myth, the legend. He is back. He's back in true effect. So, Mr. Kota,
Here we go, here we go, here we go.
take it away.
We are back, we are back, we are back. People ask what happened. ESCOM happened. Welcome to SA, the most beautiful country in the world with no electricity. Yay! Let's go! Let's go, let's go, let's go. Right, pay attention. We are back. Grade 10s. Right. We start in 3, 2, 1. Let's go. Woo, let's go. This is where you start. Listen to me. This is where you begin. The first thing you do is you drop your 90 degrees against your x-axis, not against your y. So that is step number 1. Do not write. Do not write. Watch what we do. The second thing we do is we call this x, we call that y. So x is minus 3, y is 5. Quiet. Step 1, step 2, step 3. Wait, there's 2 more steps. So step number 1, you drop your 90 degrees on your x-axis. Number 2, you label your coordinates, x and y. Number 3, you insert it on your diagram. Quiet. Step number 4. I'm giving you steps, what to do. Shh. Step number 4, we always work with theta inside the diagram, never theta outside. So if we find this one and they want that one, we'll just say 180 minus. Quiet. So step number 4, check where your reference angle. Check theta or alpha or beta. Check where it is. Step number 5, the last step. Let me see, do I have space here? Eish, I do. Pythagoras to find the last side. So now, h squared is, I'm doing step number 5. I'm doing step. These are your steps. Before you even begin with these questions, start with the steps. I'm showing you, I'm actually even writing it out for you. All you have to do is learn the steps and apply. So h squared, the square on the hypotenuse, is equal to 5 squared plus negative 3 squared. H squared is equal to 25 plus 9. H squared is equal to 34. h is equal to the square root of 34. So here we go. We found h. We found h. H is no longer h. My hypotenuse is no longer that. We now call it root 34. One more thing. One more step. 5. Number 6. Label opposite, hypotenuse, adjacent. So that's my opposite, that's my hypotenuse, that's my adjacent. So there we go. We got 1, 2, 3, 4, 5, 6 steps. How many steps? Right. Now we start answering the question. Now we just substitute. Once your diagram is complete, now we start answering. Now we just use Sohcahtoa. What do we use? Right, watch. See now how easy is it. Here are your answers. But you have to complete. This is compulsory. To do these steps. Answer to question number 1, sine theta. Sine theta is what according to Sohcahtoa? Opposite over hypotenuse, yes or no? So opposite over hypotenuse, 5 over root 34. Final answer, your first 2 marks. We just substitute. Question number 2, cos theta. Adjacent over hypotenuse. Adjacent over hypotenuse. Number 3, tan theta. Opposite over adjacent, Sohcahtoa. Opposite over adjacent, 5 over negative 3. But we never leave a negative in our denominator, so positive divide by negative, negative 5 over 3. You must remember this. Something good for you to know in algebra. Don't leave a negative in your denominator. In your final step, positive divide by negative will make the whole thing negative. Number 4. Onliners, are we back? Are we in the game? Are we back in the game? Are we back in the game, onliners? Well done. Well done. Give us a thumbs up. Hit us up in the comments. All of you. Rest of SA, where are you coming in from? Yebo. Mr. Lollipop. Next one. Watch. I don't have space, so I'm erasing number 1, 2, and 3. I'm going to do number 4 on the top. Find theta. So we got 6 marks already. I'm doing question number 4. Find theta. Now watch. Whenever we're looking for an angle, we use the shift key on your calculator. So you can do sine, cos, or tan. Whichever one, it's the same angle. Which one do you guys want? Let's use sine. Sine theta is equal to 5 over root 34. So theta is equal to shift sine 5 over root 34. That's what you're going to plug in on your calculator. So there's your calculator work. Let's go to our calculator. Make sure it's on degrees on the top. Shift sine fraction 5 over root 34. Boom. 59,03. Right, so let's just say 59 degrees. So this angle here is 59. Watch here. That angle there is 59. So what do you think the theta in the question is? Don't these two angles add up to 180 degrees? So therefore theta in the diagram, Therefore, theta in diagram is equal to 180 minus 59. Angles on a straight line, adjacent supplementary. Angles on a straight line, angles on a straight line. So 180 minus 59. 121 degrees, 121. So therefore, this angle here is 121 degrees. We had to say 180 minus 59. Let's do the last one. Substitute for 4 marks. Substitute for 4 marks. Let's do question number 5. Right, I'm answering question number 5. 2. Sine theta is opposite over hypotenuse. Tan theta is opposite over adjacent. And you can do this. You are allowed in your exam to write this. So 2 into opposite over hypotenuse, 5 over root 34. That's sine. All over tan, opposite over adjacent, minus 5 over 3. Right, now they say without the use of a calculator. So what do you have to do now? You've got to simplify this using algebra. Algebra. Now we're going to use algebra. Now this will test your algebra. Watch. We know that that is 2 over 1. How do we get rid of minus 5 over 3? We multiply it by minus 3 over 5. Reciprocal. What I do to the denominator, I do to the numerator. So that and that will cancel, that and that will cancel. Now we simplify this. 2 times minus 3 is minus 6 over 1 times 5 is 5 into 5 over root 34. We're not yet done. We can simplify that further. That and that will cancel. Numerator times numerator. Denominator times denominator. And that is your final answer. Take this down.
What's for lunch, Mr. Kauter?
Lollipop.
Not snotkop today.
No snotkop, lollipop.
Okay.
I hope you guys remember snotkop from yesterday. How to factorize. The factor of the first, the factor of the last that when cross multiplied will give me my middle term, my 2 tears and the 2 snot. Thanks for reminding me, hasanain.
Mr. Snotkop.
Master Snotkop in the house. Okay. I'm going to give you another one like this. I'm going to give you one like this and let's see if you can do it on your own. Right. I'm erasing the diagram. I'm erasing the diagram.
Are we looking without time, Mr. Kauter?
Ah, we are fantastic. We are absolutely fantastic with time. I'm going to give you that as T. I'm going to call this whole angle here as angle beta. But I told you we work with beta inside. We never work with beta outside. Right. I'm going to give you T's coordinates. T is this point here. T is 4 and minus 6. Right, here goes your questions. Here goes your questions on this diagram, and I want all of you to try it on your own. Let's see if you've mastered what I taught you. Right, here goes. Question number 1. I want sine beta. Number 2, I want tan beta. Question number 3, find the value of beta. Find beta. And the last question here. Find minus 3 cos beta over tan beta. No calculator. Right, 2 marks, 2 marks, 3 marks, 4 marks. 7 and 4. 7, 8, 9, 10, 11 marks. 11 marks on this one question. Go for it. Do what I taught you. Copy and paste. Look at the last problem, look at this problem and get it all right. We are moving on fantastic time. Where are we? 12:22. No stress. Okay. Let's go. We've got about 2 or 3 more concepts to do. Who's done? Let's check our onliners. Are we doing their online? Are we doing their onliners? Akona, you'll get 100% on this. Easy like 1, 2, 3, Baba. 1, 2, 3. Okay. We're going for break at 1 o'clock. Steve says, thank you. We're learning a lot about trigonometry. It's simple. All we're doing is we're applying. Right. Let's go. What did I say? Step number 1. Step number 1, drop your 90 degrees against your x-axis. Step number 2, x and y. X is 4. Y is minus 6. Opposite, adjacent, hypotenuse. We're working with beta inside. And let's say h squared is equal to 4 squared plus minus 6 squared Pythagoras. H squared is equal to 16 plus 36. H squared is equal to 52. H equals square root of 52. There we go, we're done. Now we start answering the questions. Sine beta equals, according to Sokotoa, opposite over hypotenuse. Opposite over hypotenuse, minus 6 over root 52. Number 2, tan beta, according to Sokotoa, opposite over adjacent, minus 6 over 4, which is equal to minus 3 over 2. Beta, I'm going to use, I want a positive, so I want to use cos, isn't it? Cos is adjacent over hypotenuse. Cos beta is equal to adjacent over hypotenuse. So therefore, beta is equal. I could have used sine, cos, or tan. I just chose cos. shift cos 4 over root 52. 56,3. But beta in the diagram is the reflex. Beta is the reflex angle, which is equal to 360 minus 56,3. 303,7. And there we go. There we go. You all know what is a reflex angle greater than 180, greater than 180 but less than 360. Okay. And there we go. I hope you got all 11 marks for that. Right. Let's choose some examples. So this is done with the diagram, right? Easy. Easy peasy, lemon squeezy, pumpkin squeezy. Next one. Watch here. Here are some exam questions. Question number 1. Solve for theta. If theta is an element of 0 to 90 degrees. Question number 1, sine theta equals 0,3. This is easy. Number 2, 2 cos theta equals 1,6. Question number 3, tan 3 theta is equal to 1,2. Right, let me show you how to do these. That's 2 marks, 3 marks, 3 marks. 3, 6, and 2, 8 marks in total. Let's do it together. Watch how we do it. Right, watch here. Let's answer the questions here. Sine theta is equal to 0,3. So theta is equal to, because we're looking for an angle, we use the shift key. Shift sine 0,3. Shift sine 0,3. They don't say without the use of a calculator. So please take out your calculators. Make sure that your calculators are on degrees on the top with the D. 17, and they might say 4,6. Correct, if they wanted it, say correct to 2 decimal places. So you look at the third number after the comma. Right, now pay attention. Let's do number 2 and 3. Very simple. No need to draw a diagram here. These are straightforward Trig questions. Number 2. 2 cos theta equal 1,6. So cos theta equals 1,6 over 2. This is what we call standard form. Pay attention. Standard form is trig function of an angle is equal to a fraction. A ratio. That is what we call standard form. So therefore theta is equal to shift cos fraction 1,6 over 2. Boom. 36,869, 36,87 degrees. Trig function of an angle, sine, cos, or tan, alpha, beta, theta, and you must have a fraction on the other side. This is what we call standard form. Now this one here is already in standard form. Trig function of an angle is equal to a fraction or a decimal. So let's answer question number 3. Watch here. Immediately we say shift tan 1,2. On our calculator, we say shift tan 1,2 equals. So watch what we have. Watch this one. Pay attention. Put your pens down. Your angle is 3 theta. So 3 theta is equal to, that's your angle. Shift tan 1,2. Let's go. Shift tan 1,2. Boom. 50,19. Or 50, let's leave it as 50,19. But we don't want 3 theta. What do we want? So now we divide it by 3. And what I do on the left, I do on the right. So theta is equal to 50,19 divided by 3, 16,73 degrees. Learn. Right, watch here. I'm going to give you another one, number 4. Let's see if you can do number 4 on your own. Right, here's question number 4. Let's see if you can do this one. Solve for theta for 5 marks. It's not difficult. It's not difficult. Get it in standard form. Use your shift key. Here's your reference angle. Where's your reference angle? There. Let's see who's the boss. You get this one right here. You're a boss. I'll give you a lollipop. Pin pop cherry, Baba. Pin pop cherry. That's your question. Here's your answer. Right, let's see. Onliners, how are you doing?
We're rocking and rolling there. We're rocking and rolling, Mr. K.
We're rocking and rolling here, bro. We are rocking and rolling.
We're eating that
Easy
wave.
basics, Akanya. You can't read what I wrote. How? 2 sine 2x plus 10 minus square root 3 equals 0. Can you see that? What? Oh, solve for x. Right, wait. Solve for x. That's your question. Here's your answer. Let's see. Right, I hope that's better for you. Can you see now? Who was that? Who couldn't see? Zayana, are we good? Let's go. It's worth 5 marks. It is worth 5 marks. I'm going to give you 2. Guys, in fact, let's see. That's question number 1. Question number 2. 3 tan theta over 4 minus 2 equals 0. And number 3, 2 tan 2x. 2 tan 2x minus 6,04 is equal to 0. Right. Solve for x, and solve for theta. Let's go for it. 5 marks, 5 marks, 5 marks. 15 marks on the screen. 5 marks, 5 marks, 5 marks. You can use a calculator. So no diagrams involved here. Right, let's see. Onliners. Easy peasy like a cheesy lemon squeezy. Same one. Same one. Dala it. Crack it. Get 15 marks here. On the take, for the take. Tell me. Seth, how's it? Let's go, let's go, let's go, let's go. We're going to do this. Then I'm going to give you a diagram. And that's going to take us right through until lunch. Now that you guys understand what trigonometry is all about, now you can go back to school and your teachers can do a whole lot of work with you and examples. Right. Here goes. Let's see. Who's done there? I got it. Lusanda. Lusanda, all three. Like a boss. Lusanda Butalesi. You done? Okay, let's go. Can I do the first one for you? Right, so 2 sine. We have to put it into standard form. Is equal to, this will go on the other side as root 3. Now we divide by 2. What I do on the left, I do on the right. So sine 2x plus 10 is equal to root 3 over 2. I'm just moving over to the side because I don't have space. 2x plus 10 is equal, that's your angle. That is your angle. Shift sine root 3 over 2, you know, is 60 degrees. Shift sine square root 3 over 2 is 60. Let's solve for x. 2x is equal to 60 minus 10 is how much? 50. Good. X is equal to how much? 25. How many of you got that one right? Well done, well done, well done. Give yourselves a nice round of applause. Well done. Well done. Where you didn't know anything about trigonometry, you were completely blank. You're getting a higher order question worth 5 marks. Let's see if you can get the next 2 right. Come, if you thought you got the first one right, get the next 2 right. And that will take us to the end of, we only got one more component of trigs to do. Then we go for break. We go for lunch. Okay. Are you ready? Are you ready for number 2? Are you ready for number 2? I'm erasing it. Let's see. Onliners, how many of you got that one right? Well done. Mo Shandu or Ma Shandu. Ma Shandu. Zayana Rahman. Well done, well done, well done. Any other onliners got it right? Hit us up in the comments. Let's see. Where you at, bruh? But the alam, well done, bro. Well done, well done. And I hope you guys are not lying and cheating. You're only lying and cheating yourself. Right, let's go, let's go, let's go, let's go. We're doing number 2. You should be ready. Okay. Number 2. Let's do number 2. 3 tan theta over 4 is equal to 2. I took that 2 on the other side. Times 4 times 4. So 3 tan theta is equal to 2 times 4 is 8. Divide by 3, divide by 3. Tan theta equals 8 over 3. There's its standard form. Now theta is equal to shift tan. 8 over 3 equals 69,44 degrees. How many of you got that one right? Well done, well done. Give yourselves a round of applause. Let's go, let's go, let's go. Last one. Last one. Onliners, did you get that one right? Onliners, did you get that one right? Melbourne Production, well done. Raisu, well done. Abdul Malik, well done. Tando, you got that one right. Last one. Melvin, well done. Click the like, click the subscribe, guys. Hit the like, hit the subscribe on YouTube. Well done, Badri Alam. Well done, Safia. Absolutely amazing. Now you're getting it right. Now you know what you're doing. Yo, Mawande, you're a boss. Why do people laugh? Do you know Mawande? Who is Mawande? Oh yeah! Ooh, Hasanain, did you hear that? Did you see that one, Hasanain?
What were they saying?
Mawande is sitting here in the crowd here, brah. Point there to her. Let
Call her back. Give us a wave.
Mawande. Where's Mawande?
Yeah.
Where's she going there under the...
MashaAllah. Keep it up. MashaAllah. Well done.
Well done, well done, well done. Thanks, Mawande. Let's see if you got the last one right. I knew something was up. Every time Mawande's name came up, I heard everybody laughing. I'm thinking to myself, something is up there in the back. I just said, who's Mawande? Everybody just said, there.
There's another Rory song.
Last one.
Another Rory song in the making.
Another Rory song in the making. 2tan 2x is equal to 6,04. Tan 2x, that's our angle. That's our angle. Tan 2x is 6,04 divided by 2. So 2x, our angle is equal to shift tan 6,04 over 2. We get 71,678. 71,6789. I'm not rounding up now because I want my answer to be as accurate as possible. So x will equal to that divided by 2, 35,83. Let's call it 35,8. 83848. No problem. 35,8 degrees. Did you guys all get that one right? Well done, well done, well done, well done. Okay. Let's do, we've got 15 minutes left, right? I want you to pay attention to the next two that we are going to do. I want you to pay very careful attention because we're wrapping up trigonometry. We're now at the end. We are 90% through. I got two components, one for 5%, one for 5%, and we're done. So hang in there. We're almost there for break. Okay, watch. Onliners, we all right? Got it. Well done, well done, well done, well done, well done. So here goes. Shh. Now pay attention. Oh, you guys got to pay attention to this. Now you got to pay attention. I'm just waiting for the, there we go. Pay attention, pay attention. If cos theta equals -3 over 5, and theta is less than equal to 180 but greater than or equal to 0. Find number 1, sine theta, and number 2, 2 tan theta plus 1. No calculator. Question 1, question 2, 3 marks, 4 marks. Total marks 7. Now pay attention, put down your pens. Now you have to use a diagram. In the first one that I gave you, the diagram, the line was given. The diagram was given, you had to complete it. Here you're going to draw the diagram from scratch. So I'm going to teach you a mental acronym for the steps. Watch here. Whenever we need to draw a diagram, you use what we call scrap. I know your teachers, this is my own acronym for your mental steps. S for Sokatoa. And standard form. C for Cartesian plane. R for restriction. There's your restriction. A is just for and P is for Pythagoras. So you use scrap when we need to draw a diagram. So let's do it. Don't write. I'm only doing one example. Your teachers will do more examples with you at school. Pay attention. Right, here goes. Now, put your pens down. All of you, onliners as well. Put your pens down. Follow what I'm about to do. Do I have your attention? Good. Let's go. Check here. Sokatoa, cos is adjacent over hypotenuse. Yes or no? So I'm done with that. Standard form, it is. Trig function of an angle is equal to a fraction. So we're good. Cartesian plane. Let's draw the Cartesian plane. Restriction. Theta is less than 180 but greater than 0. Now you all know ASTC. Yes or no? All positive in the first quadrant. Only sine positive, everything else negative. Only tan positive, everything else negative. Only cos positive, everything. This is your Cartesian plane. We go in that direction. ASTC. All students take Coke. Right. Don't forget that. Right. Now watch. They tell you less than 180, greater than 0. So it could be there or it could be there. There's your restriction. But where is cos negative? In the first quadrant, all is positive. We can't draw it here. That means it has to be drawn in your second quadrant. Because this is less than 180 and cos is negative. So a double tick. Less than 180 and cos is negative because only sine is positive. So we draw that. Now pay attention. Here we go. That's angle theta. Adjacent. Opposite, hypotenuse, adjacent. Adjacent over hypotenuse. Adjacent over hypotenuse. And now we use Pythagoras to find the opposite side. So let's call that our y value. So 5 squared is equal to y squared. Square on the hypotenuse is equal to the sum of the other two squares on the other two sides. There we go. We're doing Pythagoras. 25 is equal to y squared plus 3 squared minus 3 squared is 9 Y squared equals 25 minus 9, 16. Y is equal to plus or minus 4. It's the positive, it's above, so it has to be 4. If it was below, it would be minus 4. It's above, so it's 4. So we use scrap. What do we use? Standard form, Cartesian plane, restriction, and Pythagoras. All right, take this down. Take this down. Now, I want you to answer these two questions. Answer question number 1, answer question number 2 after we draw. Compulsory, you must draw the diagram. You must draw the diagram.
How are you doing, Mr. Kota? How's the energy levels? How's the
All
vibes?
good, bro. All good. We are still fully fueled. Fully fueled. Fully fueled. I can see some of them now are getting a bit. I know they're spinning. They look like they've been dropped with an atom bomb on their head. But we are 7 minutes away from break. We're 7 minutes away from break. And I told you, every time your brain tells you to shut down, you need to say, shut up. Right.
That's how we do it. That's how we do it.
That's how we do it, bro. Onliners, are you still there? So glad to see everyone on a Sunday doing math, a grade 10 on a Sunday. Yo, welcome to Math Church, bruh. I'm the pastor, Pastor K.
Mr. Kota, it's the Comrades Marathon, I believe, next week sometime in Durban, from Pietermaritzburg to Durban.
Are you taking part, hasanain?
Virtually, I'll be taking part.
Virtually.
But maybe next year sometime. But look, this is a comrades of another
I'll
sort.
be with the Comrades Marathon in heart and soul.
Yeah, no, but this maths workshop is another sort of a comrades marathon, a duel with
Hasanain,
the
how did
mind.
you manage past 3 weekends, bumper to bumper, all 3 weekends, different parts of SA? I must take, guys, I think we all need to give Hasanain a nice round of applause for him sitting through 3 whole weekends, guys. Give him a nice round of applause.
Yeah, no. It's for the benefit of the Awqaf project as well
Imagine,
as for our
Hasanain,
learners.
the learners are saying they hate going to break. Where did you ever hear a learner saying, I hate going to break, give us more maths? Are they okay? Is alles all right by die huis? Right, here we go. You took it down. Let's answer our questions. Right, sine theta. Let's do the answers here. Answer to question number 1, sine theta. Opposite over hypotenuse. Opposite over hypotenuse. What did we get y to be? 4. That was 5. That was -3. So opposite over hypotenuse. 4 over 5. You can leave it like that, or you can say 0,8. 4 over 5, 0,8. No problem. They'll give you marks for both. Number 2. 2 tan theta plus 1. 2. Tan is opposite over adjacent plus 1. I'm doing it on the side. This is equal to 2. Opposite. Where's my opposite? Opposite over adjacent. 4 over -3 plus 1. 2 times 4, 8. 1 times -3, -3. Plus 1. minus 8 over 3 plus 1 minus 8 over 3 plus 1 minus 5 over 3. And that is your final answer. Did you guys get that right? Yes, well done, well done. Right, we got 4 minutes to go. We've got 4 minutes to go. Right, I'm going to leave you with something. I'm going to leave you with something. Watch this. The last question in Trigs, you don't have to finish it now. Even after break, you can come back and we can finish it. But take it down now with me. You must know this. Right. Watch here. They give you a diagram. They give you that. They give you from there to there. They give you from here to here. They tell you that is parallel to that. This is point D. That's point C. That's 90 degrees. That's B. This angle is 12 degrees. This is 55 meters, the height. This is A. That is K. So now they can tell you, listen to me, they can give you a story. They can say AB is a vertical cliff. Listen to me. AB is a mountain, is a vertical cliff. The ocean is here. Quiet. Come on, girls, quiet. We're finishing up. Right. So AB is a vertical cliff. Right. D is a boat on the water. The water is DB. D is a boat on the water, DB. C is a man that's drowning. Right. Find the distance between the boat and the drowning man. Find the distance between the boat and the man drowning. If this is 48 degrees, from the man drowning to the top of the hill is 48 degrees. Find the distance between the boat and the drowning man. It's worth 6 marks. We are moving on fantastic time. It's 1 o'clock on the dot. Yes, like I told you yesterday, we'll finish everything. We are exactly on time, guys. Not a second later. Guys, we're going to go for a break until 1:45. Maybe we'll give you a 1 hour break. Take a lekker 1 hour rest. 2 o'clock, we resume. I finish this question and we do geometry. Okay. Okay, guys, enjoy your break, enjoy your break, enjoy your break. Those who want to pray Salah, Zohar Salah, you can go up to the masjid. at the school. Okay, guys, we are off for break. Hasanain, I see you after break. I'm going to leave this on the screen. Onliners, try and crack this one. Yes, Safia, we're getting an hour break now, 1 o'clock to 2 o'clock. Enjoy your break. Assalamu alaikum. We resume at 2 o'clock. We resume at 2 p.m. See? No, it's fine. After. Yeah, we can do after. No, you want to do that. Right. I just want to go to the bathroom. Okay. Here we go. We are back. Just watch out there. What's happening there? Just switched over. I think we just switched over. Come on, boys. Grade 10s. The boys on the Astro there with the ball, come. Let's go. Break is over. Okay. What's going on? Let's go back. We're in the show. We're resuming now. Okay. Let's just give it a couple of seconds. Boys there on the Astro. The break is over. We're just giving it let's give it a minute or so for everybody to settle down, settle in. Here we go. Ready to work, Melvin. Melvin is back. Welcome back. Sam, Pilar, wish I was there. Sadia Go, Lita, Jada. Let's go. We're back. Our last session for today. Okay, grade 10, settle down. We start in 5, 4, 3, 2, 1. Right, thank you. Here we go. Find the distance between the boat and the man drowning. Basically, you need to find DC. Thank you, grade 10s. There's still too much talking. Here goes. Thank you. If you guys are going to miss this, you're going to miss a big component for your exam. Right. We need silence there. Thank you. Boys here on my left. Right. Settle down. Okay, let's go. Onliners, are we back online? Give us a thumbs up there. Ready to work, Melvin. Right, so you are back. Safia Gul, you back in. Let's go. Pilunhle, Gumbi, back. Let's go. Right. Pay attention. Right. We need to find DC. Now listen to me. Now listen, what you need to do is identify your triangles. We need to fill these two. We've got two big triangles. Listen. 90-degree triangles, we got the big triangle. The big triangle is ADB. And we've got the smaller triangle. Grade 10s, there's still a lot of noise coming from the back. Here we go. And then we've got triangle ACB. This is 48 degrees. This is 55. This is also 55. Shh, quiet. Okay. Let's fill out as much information as we can. We know from there to there is 90 degrees. Quiet, pay attention. In the small triangle, that's 90, that's 48. So what is this angle here? Sum of angles of a triangle. So 180 minus 48 minus 90. 42 degrees. So CAB, you can write it here, angle CAB is equal to 42 degrees, sum of angles of a triangle. So we know that this angle here is 42, because that's 90. So that angle is 42. How much is this angle? KAD. Angle KAD is equal to 90 minus 42 plus 12. So 90 minus 42 minus 12, 36 degrees. So we go here and we put 36 degrees. There's still great ends. Right, here goes. Now that line is parallel to this line. So if that is 36, this angle here is 36. ADC is 36. Angle ADC is equal to 36 degrees, alternate angles. Alternate angles. This angle and that angle are alternate to each other. They are equal. Great ends. Thank you. Right. We need this side here. I can find this side first. So I'm going to find CB first. I am going to find CB first. So I'm going to do it like this. I'm going to say in triangle ABC. So we're telling the examiner to look into that triangle. That's this triangle here. Tan of 48. Oh, I can use 42 as my reference angle. Tan of 42. I can go tan 42 is opposite over adjacent is equal to BC over AB. It's my opposite over adjacent. So tan 42 is equal to BC over, what is AB? AB is given. How much is AB? 55. Very good. So I want BC on its own. I don't understand why they're talking there at the back. It's disturbing me here in the front. Thank you. So we want BC on its own. The opposite of division is multiplication. I'm going to multiply this by 55. What I do on this side, I got to do on the left. So BC on its own will equal to 55 tan 42. So what is BC equal to? Go to your calculator. 55 tan 42. 49,52. So BC is 49,52. I need DC, the distance between the boat and the man drowning. Okay? Now let's look at the big triangle. Now let's look at the big triangle. So I'm now going to say in triangle. So let's go, big triangle. In triangle ADB. Now I'm going to look at 36 degrees. Right. Tan of 36. Remember, if this is my reference angle, that's my opposite, that's my hypotenuse, this whole last side is my adjacent. So tan 36 is equal to opposite over adjacent. Can you see how we're using trigonometry to sort this out? So tan 36 is equal to your opposite, which is 55, over your adjacent side is dB. Now be careful, we're solving for dB. So we flip this side, we flip that side. dB over 55 is equal to 1 over tan 36. I want dB on its own. The opposite of division is multiplication. So I'm going to multiply there by 55. What I do on the left, I do on the right. So dB on its own, the entire length dB, let's do it here. Let's solve for dB. dB is equal to 1 times 55 is 55 over tan 36. How much is dB, the entire side? So 55 divided by tan 36. 75,7. Now dB, the whole thing is 75,7. They want DC. If the whole side is 75,7 and that small piece there that we found was 49,52, what do you think this is going to be? Here's your final answer coming up. DC is equal to BD, the entire side, minus the small piece, BC. So what is BD? 75,7. What is BC? 49,52. Here's your final answer coming up. DC, the distance between the boat and the man drowning. 26,18 meters. And that's your final answer. You will get 6 to 8 marks for that in your exam. So you got two 90-degree triangles. We use trigonometry to find the value of the sides. And then we use logic to determine what they are asking you for. Read your questions carefully. Read your questions carefully, and this is an exam question from a past paper. This is an exam question. This is the last question in Trigs. So they give you one with a Cartesian plane, which we did. They give you the trig equations, which you need to solve. They gave you your other trig equations, which you need to simplify or solve. And now they gave you this one with a diagram where you use SOHCAHTOA. This is a real life situation. So even those of you who are doing IEB, those of you who are doing Sakai, which is distance education, this is for everybody. You all need to know this. Every grade 10 in the country needs to know this. Are you all with me? Good. How's our onliners doing there? Did you guys get that? Onliners, do we get a thumbs up from you? Did you understand how we got DC? Small triangle to get the small side. Big triangle to get the big side. Big side minus small side is equal to back side. Is equal to DC. You all got it? Excellent. Excellent. Right, take it down. Some of you are still taking it down. we are going into geometry. We are going into Euclidean geometry now, and that's going to take us right through until the end of the session. It's 2:15. Now remember, Euclidean geometry includes all the geometry you've ever done from grade 5. Lesson? So you need to know the sum of angles of a triangle. So let's put down all your theorems that you need to know. StreamYard, let's go, let's go, let's go. Abdul Malik, well done. Peter John, well done. Safia, well done. Lapoka, well done. Pilunhle, Gumbi, well done. Lapaka, let's go, let's go, let's go. I'm clearing the frame. Right, now listen to me. What do you know in geometry? Now these are the things you eat. This is your think box. This is your toolbox. So let's put it, what do we need to know in our toolbox? The first tool that we need to know, you know that angles on a straight line, 1, 2, 3, angle A1 plus angle A2 plus angle A3 is equal to 180 degrees. Angles on a straight line, but we can say adjacent supplementary. That's the reasoning that we use. Adjacent supplementary means angles on a straight line add up to 180 degrees. The second thing that you need to know, angle B1 is equal to angle B2. What is that? Isn't that vertically opposite? Good. And what do we know about vertically opposite angles? Do they add up to 180 or are they equal? They are equal. Number 3. We need to know that 1, 2, 3, 4, 5. Right, let's call this M. M1 plus M2 plus M3 plus M4 plus M5 is equal to 360 degrees. It's a revolution. Angles around a point. Angles around. When I say that's my abbreviation for angles. Angles around a point. Right? Angles around a point. Right? That's 1, 2, 3. Shh. You have to know this. If you don't know this, you'll be applying this from now till matric, till grade 12. What else is in our toolbox? So we've got a lot in our toolbox to use. Right. Let's now go into triangles. Let's talk about a little bit about triangles. So we've got number 1, number 2, number 3. Can I erase? Onliners, are you busy? Are you done? Can I clear the frame, onliners? 1, 2, 3. Okay, I'm sure you all did number 1. Right. Very important, the next one. Very important, the next one. Angle P, angle Q, angle R. We know angle P plus Q plus R is equal to 180 degrees. Sum of angles of a triangle add up to 180. Right. This is number 4. Let's do number 5. Let's do number 5. Very important. Let's call it angle A, angle B, angle C1, angle C2. The exterior angle of a triangle is equal to the sum of the interior opposite angles. That angle is equal to angle A plus B. So angle C2 is equal to angle A plus angle B. And that is the exterior angle of a triangle is equal to the sum of the interior opposite angle. Right, that was number 5. That was number 5. Let's do number 6. This was number 5. Let's go into number 6. What else do we know about triangles? We know that when two sides are equal, the angles opposite the given side, we know that's an isosceles triangle. Why is it talking here? The isosceles triangle. So we know A, B, C, angle B is equal to angle C. That angle is equal to that angle. The angles opposite the equal sides of an isosceles triangle are equal. Right. We're not yet done. Our toolbox is not yet full. Our toolbox is not yet full. We still got to do parallel lines, bruh. You forgot about that. And we're not yet done. We still got to do congruency, bruh. And you're not even done with that. You still need to know a line drawn from the midpoint of one side to the midpoint of the other. Did you guys do the midpoint theorem in school? It's parallel to the third side and half the third side in length. And then our toolbox is not yet full. We still need to know quadrilaterals and parallelograms. Yeah. That's how you fill your toolbox. That's how you fill your toolbox. Right, let's go. 4, 5, 6. Number 7, let's talk about parallel lines. So we're done with triangles. Right. 6, number 7. Parallel lines.
I'm back.
Are you back? Welcome back. How's it, hasanain?
We're all good. We're all good. We're all good.
A1, A2, A3, A4. B1, B2, B3, B4. Right. Now you know the F shape. The F shape. If those two lines are parallel, that angle is equal to that. So A3 is equal to B4. A3 is equal to B4 corresponding. And they are equal. We also know that A2 will equal to B3. We also know that, so as long as it's on the same side of the transversal, this line is called the transversal. So as long as the angles are on the same side, both above or both below, it's called corresponding, and corresponding angles are equal. The next one, FUN, these two lines, that's your transversal. X plus O. Same side of the transversal, one above, one below. So there's the U, there's the U. So A3 plus B2, A3 plus B2 is equal to 180. And that is what we call co-interior angles. They are not equal, they add up to 180. X plus O. There we go. There's the U. X plus O. A2 plus B1 add up to 180. The last one, the N or the Z, the N, F-U-N, fun. Opposite side of the transversal, one below, one above. So there's your Z shape. Let's do it in a different color. There's your N or there's your Z. We know B1 will equal to A3. Angle B1 is equal to A3. We also know A2 is equal to B2. Angle A2 is equal to B2. And they are alternate angles. Alternate angles. And what do we know? They are equal. So corresponding are equal. Alternate are equal. Co-interior angles add up to 180. Number 8, congruency. You know the 3 rules. Congruency is to prove that 2 triangles are identical. Who knows what are the 4 rules of congruency? Side, side, side. Side, angle, side. And the angle must be the included angle between the 2 sides. Angle, side, angle. And who knows the last one? Very good. Right angle, hypotenuse, side. Well done. Well done. Well done. So these are your 4 laws of congruency. Now we're going to do, before we start with some problems, let's do the last one, the midpoint theorem. The last one, the midpoint theorem. And then we start with problems. So it's 2:30 on the dot. We got 25 minutes to go. We'll see as many as we can do within the next 25. It will fly. Time will fly. Onliners, I hope you're taking all this down. Yes, Albert. Right angle hypotenuse side. Kotso. Danko. Let's go, let's go, let's go, let's go, let's go. The last one, watch here. Thank you, great chance. Don't worry. This is the last 25 minutes for our program, our 2-day program. After this, it's game over. Right, watch here. This is what we call the midpoint theorem. Have you guys done this in school? How many of you have not done this? Okay, but let me explain it to you. Hey, quiet. Guys. All right, I'll wait for you. I will wait for you. A, B1, B2, C, D, A, B, C, D, E, E1, E2. Now, here's the midpoint theorem. Listen. A line, we're talking about BE. We're talking about BE. What line are we talking about? Right. So here's the midpoint theorem. A line BE drawn from the midpoint of one side of a triangle Here we go. Midpoint. From the midpoint. Pay attention. Those of you who haven't done it, please pay attention to this. A line drawn from the midpoint of one side of a triangle to the midpoint of the other side, to the midpoint of the opposite side of that same triangle. Right. So what about it? What is so special about this line now? If a line BE, we're talking about the line BE, from the midpoint of the one side to the midpoint of the other side, it becomes automatically parallel to the third side, becomes parallel to the third side, and half the third side in length. Very important. This is core grade 10 work. You're going to use this till grade 12. So it becomes parallel to the third side. And if the third side was, say, 100 units, how much will this be automatically? 50. So it becomes half of it. So a line drawn from the midpoint of one side of a triangle to the midpoint of the opposite side becomes parallel to the third side and half the third side in length. The converse also applies. The converse means the opposite. I'll show you what the converse. What do you think the converse is? A line from the midpoint of one side parallel to the third side will go to the midpoint of the opposite side. That's the converse. The actual theorem is midpoint to midpoint to become parallel. The converse will be midpoint parallel will go to midpoint of the opposite side. It has to be the same. So I'll show you what the converse of this is. I'm not going to show you the proof of this. The proof you can ask your teachers. It's bookwork. You just need to learn it. There's some construction involved. You need to know how to prove this for your exam. Shh. You must know the proof. You'll ask your teacher. It's in your textbooks. Okay. I'm going to show you how to apply. Now let's look at the converse of this. So you've taken this one down. So then what would the converse of this one look like? The converse, A, B, C, D, E. Right. We're still talking about the line BE. A line drawn from the midpoint of one side parallel to the third side. Here we go. Now let's write the converse of this. This is the converse of the midpoint theorem. Right. You take too long. How long does it take you to write 2 sentences a day? Right. A line, we're still talking about BE, drawn from the midpoint of one side. Take this down. Parallel to the third side. Now they tell you it's parallel. Bisects the opposite side. That means it goes to the midpoint of the opposite side. Bisects the opposite side. And this is the converse of the midpoint theorem. You need to know both. You need to know both. In 2 days, we've done 6 months' work. The next workshop, there'll be much more work, and the one at the end of the year, we're only doing past papers. Applying all this. Remember, you guys must still do finance in school. You must still do probability for paper 1. Paper 2, you must still do trig graphs. You must still do data handling. Depending if your school has done it or not. Okay, so here goes. Shh. Now we start with the application. Guys, we only got 15 minutes left. It's already 25-2. It's 14:36. We're already at the end. At 5-2, we are done. Right, quiet. Right, I'm erasing. Let's start with the questions. Come on. Here's the first one, exam. Let's put here exam. Right, here goes, here goes, here goes. Take that down. Let's all do it together. I'm not going to give you anything to do by yourself for now. For one reason is that we don't have time.
I'm singing your praises, Mr. Kota.
I can't see the comments yet. I'm busy drawing this.
Okay.
RAS, that's point R, that's point A, that's point S, that's point B, that's point C. Shh. 1 4x, 1 4x. That is parallel to that. C1, C2. A1, A2. This angle here is x plus 60, and this is angle x. Right, there we go. Solve for x. Solve for x. For 4 marks. Let's start solving for x. Right, while you guys taking this one down, I'll give you guys about, this is x plus 60. This is x plus 60. Let me write that a little bit better. There we go, x plus 60. That angle is 4x. That angle is x. Let's check our comments coming in. Thank you, Albert. Thank you, May Naidu. Thank you, Albert. Well done, well done. I hope you guys are all understanding, enjoying the session. We all wish you our teacher. I am. I'm teaching the entire country. I am your teacher. Time is flying too. Imagine they say you're sitting here for 2 days, you're saying time is flying too fast. Sorry, man. We only got 10 minutes or 12 minutes left. Right, let's go. What do we know? Listen. Start from what they give you. Now you automatically know you're going to be using parallel lines. Now watch here. You start from the known. Let's start from there. What is this angle related to? Isn't it related to A1, 4x? And isn't all these 3 angles added together will add up to 180? So let's write it out. Here's our answer. Angle A1 is equal to 4x. Alternate to, what was that? B2. Let's call that B2. It's alternate to angle B2. Right. So now you go there. You got A1, you put 4x there. You know, therefore, 4x plus x plus 60 plus x is equal to how much? And what is our reason there? ADJSUP, adjacent supplementary, angles on a straight line. If you want to write angles on a straight line, no problem. This is the proper mathematical way to write your reasoning. So 4x plus 1x is 5x plus 1x is 6x. 180 minus 60. 6x is equal to 120. X is equal to 120 divided by 6. X is equal to 20 degrees. And that's your final answer. You got yourself your first 4 marks. Agreed? Beautiful. Easy. Start from the known. In geometry, we start from the known, moving to the unknown. It's like you are going from, say you are leaving from Durban to Cape Town. Where do you start? Durban, because that's the known. Cape Town is the unknown. So you always, common sense tells you, you start from what is given, and then you move to your unknown. And the vehicles that you use are your theorems. Those are your vehicles. Right, here goes. I give you another one. We're going slightly up. Let's check the next one. That one was easy. Let's do another one. So we got a line going like that. And we got a line going like this. Take it down. And you've got a line coming down there. And you got a point there, and you got a line going there, and you got a line coming here. And that line is parallel to that line. This is B, that is X, that is X. That is Y, that is Y, that is D. That is F, and this whole angle outside is F1. Right. Prove that F1 equals 270. Prove that angle F1 is equal to 270 degrees for 4 marks. Now, guys, I've never done this before. I'm just taking it straight out of past papers here for you. We're all cracking it together as if we're looking at it for the first time. Quiet, 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 quiet. Right, let's see, what do we know? This is interesting, okay? They don't give us anything else. No, they don't give us anything else. Let's see, I've never seen one like this before, but of course we can try it out. We know these two lines are parallel, so I know that, let's call this, if I call this one B1, B2, I'm just calling it for explanation purposes, B1, B2, D1, D2. So we know that B1 plus B2 plus D1 plus D2 is equal to 180 degrees because it's co-interior angles. Can you guys see that? Right, now pay attention. Co-interior angles add up to 180. So x plus x plus y is equal to 180. So 2x plus 2y is equal to 180. If I divided everything by 2, what will I get? X plus y is equal to 180 divided by 2 is how much? So if x plus y is 90, x plus y is 90. So how much is angle F2? Therefore, angle F2 in this triangle is equal to 180 minus x plus y. Sum of angles of a triangle, which is equal to 180 minus. We found out what is x plus y. How much is x plus y? 90. So 180 minus 90 is how much? 90. That means F2 is 90. Now we know that angle F1 plus F2 is equal to 360. Angles around a point. So we know this is 90. So angle F1 plus 90 is equal to 360. Here comes up your final answer. Here's your final answer. We need to prove, therefore, angle F1 is equal to 360 minus 90. 270 degrees. You'll get 4 to 6 marks for that. We got about 6 minutes left. We got about 6 minutes left. Right. Let's give you one using the midpoint theorem. Let's give you one using the midpoint theorem. You can go back to school and then your schools will show you how to do the ones with congruency and parallelograms. Right? The purpose of today is to make you see what to use, how to use it. Remember, this is not the end all and be all. I'm here to make sure you understand. You're going to go back to your teachers and you're going to be doing hundreds of questions. Albert. Okay, so let's erase this.
Are you locked again?
Here goes. So they give you that, and they give you that, and they give you this, and they give you that, and that. Right, take this diagram down. A, D, E, F, B, C. A, D, E, F, B, C. Let's see what they tell us. BC equals 20. AD equals DB. AE equals EC. AE equals EC. This is the last one we're doing. FC is parallel to AB. FC is equal to 6. Find the length of DE. That's 6. Find question number 1, DE. And question number 2, AB. Again, I'm taking it straight out of a past paper. Let's do it together, and this will wrap up today's session. We're at the end, guys. We're at the end of 2 full days of crazy mathematics. Yeah. Let's go. The minute they give us that, let's go to our diagram and let's see what's in here. BC is 20. Where is BC? That's 20. AD equals BD. That is equal to that. AE equals EC. AE equals EC. Ha! We see the midpoint theorem going down here. FC is parallel to AB. FC is parallel to AB. Okay. They're getting smart. They put that. They think they're smart. FC is 6. FC is 6. Find DE. Ha! Same time. Same time. Let's answer the first question. Right. Now you're going to say AD equals BD given. AE equals EC given. Therefore, DE is parallel to BC and half of BC, your midpoint theorem. Therefore, DE is equal to half of this, half of 20, 10 units. There we go, DE is 10. Done, that's the answer for the first one. Find AB. Ah, that's easy. I got the answer already. Come on. Come on, use your brains. Use your brains. Find AB. We're at the end. We got 3 minutes left. Yes, who said that? Well done. Well done. Right, so here goes. You've taken this one down. We are now doing question number 2. We now want to find AB. This whole length here. That whole side there. Well done, well done, well done, well done, well done. So watch here. But how are you going to answer it? Answer to question number 2. Pay attention. DE is parallel, or DF. Let's go here, DF. DF is parallel to BC. We just proven above. Midpoint theorem, proven above. And then you got AB. AB is parallel to FC. There we go, that was given. Therefore, DBCF. DBCF is a parallelogram, is a palm. Right. Therefore, FC is equal to BD. Therefore, FC is equal to BD, which is equal to AD. Therefore, BD is equal to 6, because if that is 6, then that is 6. And this side and that side are equal, so if that is 6, that is 6. Therefore, AD is equal to 6. Therefore, AB is equal to 6 plus 6. 6 plus 6, the whole side. 12 units. There we go, and that has brought us to the end of our today.
Make some noise.
Online Sophia, well done, well done, well done. May I do? Thank you. There we go, there we go, there we go. I think we stand up. Let's open ourselves, guys. Round of applause. Well done, well done, well done, well done, well done. Guys, we're just going to do the vote of thanks. We are just going to do the vote of thanks. You guys have been amazing. Love you guys lots. I hope you guys get 100% in your exams. Just stay in your seats. Stay in your seats. Sit down. 5 more minutes before you people leave. We just like 2 minutes. 2 minutes. Hasanain, everything. Thank you so much, everybody.
Okay, so now we will call on Al-Falah's principal, Mr. Zafar Ahmed. He's been very instrumental, along with his team, in putting together this very important grade 10 workshop, and they've actually boasted like up to 400 learners. So well done to himself and his team. And we're just going to hand over to Mr. Zafar Ahmed from Al-Falah College. He's the principal, and he's going to be doing the vote of thanks.
Thank you very much, Hasanain, and thank you very much to all of you. This won't take too long, just 2 minutes. I think it's very important that we take a few minutes to acknowledge all of the people who made it possible for us to bring this event to you. So, it's quite a complicated and complex arrangement to set up such an event and also to have it streamed across the country and indeed across the world. So we want to acknowledge the contribution and support of a number of people. First of all, we'd like to acknowledge the support we received from the National Department of Education, from the Mathematics Department, Mr. Leonard Badao, and I'd also like to acknowledge Mr. Temba, the Maths advisor from the Mlazi district, who's been here yesterday and is here again today, and to make sure that he's facilitated all the kids. So we'd like to acknowledge your presence, sir, and your support for the program. Thank you very much. We also want to acknowledge the CEO of Awqaf South Africa, my boss, who made it possible and been driving this initiative to make sure we take maths tuition to students across the country, Mr. Zainul Abedin. We also like to thank many of our partners who behind the scene make things happen. The main engineer for this weekend, and as you heard, hasanain sitting in Cape Town, controlling all of this, was doing the same thing last weekend with the grade 11s and the previous weekend with the grade 12s. We'd like to thank him in Cape Town for supporting us. hasanain is now qualified to teach and to write the grade 10, 11, and 12 exam and get 100%. We also like to thank our partners, ISkill, Mr. Limalia. We'd like to thank Mr. Kakri for the wonderful sound and the logistical support that he provided. And also to Mr. Kakri and his team who've been on site throughout the weekend with us. We really appreciate that. Also to the Al Falah College team. You've seen our cleaners cleaning up on the bathrooms after you. The security, we'd like to thank you all. Also, the Board of Governors at Al Falah College, the IT team, my HOD for Mathematics, Dr. Singh, who sent invitations to all of you, coordinated the whole program. He was here all day yesterday and this morning. Thank you to Dr. Singh as well. I noticed in the crowd, many of your teachers have accompanied you and spent 2 days with you. We'd like to salute them and thank them as well for them. In conclusion, I also want to say how delighted I am to have you at my school. You are a disciplined, committed bunch. I'll have you back at my school anytime in the future. And finally, on your behalf, I want to thank this man for the good work he's done. We hope to have him back in November for another 2 days, helping you get ready for your November exam. God bless, take care, all the best for your exams. Smash that maths exam.
Oh man, thank you, Mr. Zephyr, for those words, quite eloquently spoken there. The one thing I must say, I really love the fear of the participants. You guys have really been awesome, and it's been really fantastic liaising with you guys, the in-person participants, as well as the online participants. So, Mr. Kota, can we reflect a little bit on the session? You know, there was really high
Absolutely
energy.
amazing.
We had American waves, we had rocket launches, took us all the way to orbit with the Awqaf SA Maths workshop. And I really enjoyed this. The energy was here. And look, my, just talk about our
Absolutely
online
great.
participants, you know. Let's give them a shout out.
Yes, now all the students that have been so engaging, Albert, Yuri, TRX, Lord, Lusanda, Tando, all, whoever has been, Melvin, Lusanda, Tando. We just want to say to all you onliners, thank you so much for all the positive feedback, for not trolling us throughout the program, zero disruptions, so that everything went we went on with laser-like precision, exactly on time, and we completed everything that we needed to do in the 2 days. Abdul Malik McPherson, I just want to say Jazakallah to Awqaf South Africa, Uncle Zainul. Hasanain, you've been amazing, my co-pilot for life. And I can't imagine doing honestly, I can't imagine doing a live online program without you. So yeah, to Hasanain, Jazakallah so much. To the team here at Al Falah, to Zafar, to Faisal, the technical, to the cleaners, to everybody around South Africa, Department of Education, everybody who put this thing together. Nabil Magda, thanks a lot. Thanks so much for your guys' positive feedbacks. Lots of love from us here. Thank you so much. The buses are all waiting there outside. Learners are all climbing on the buses and they're going to all their different. Some of the learners have traveled as far as 60 kilometers by bus to get here. So yes, it's been an amazing,
So that's
amazing,
the
amazing.
dedication. That's the dedication that's required in order to achieve greatness, to move yourself out of your conditions. And, you know, there's many bursaries out there when you get to grade 12 and you've got potential academically after grade 12. So, you know, your foundation starts now in grade 10. And I must say, the online participants, you've been awesome. You've been engaged, you've been motivated, you've been giving us lots of love, lots of energy, as well as the in person participants. So, what you do see here on screen, Mr. Kota, is the Awqaf SA YouTube platform. So, it's
Yeah,
Awqaf South Africa. You subscribe to that and you can tune into the next sessions with Mr. Kota.
absolutely.
It's as simple as that. All of our lives are on here and we'll create a little playlist with all of the maths workshops. So if you
Please,
missed
guys, go
anything,
on to the click like, click subscribe, and you can rewatch. These sessions are recorded. The whole weekend was recorded. You can watch it over and over and over and over until it's in your head and until we meet again. Let's put it that way. Until we meet again, inshallah. Jazakallah so much.
okay, so that's it, Mr. Kota. We're going to wrap that up. We thank the Almighty for granting us this opportunity
Ameen.
to do this project. It's a project not only for maths and academic excellence, it is a effort in nation building because we can produce the best scientists, engineers to solve some of our problems that we do have. Any
Absolutely.
concluding words there from you, Mr. Kota? It's been an absolute pleasure working side by side with you. I've got to respect your craft. Salute.
Salute. We are match made in heaven. Alhamdulillah. I mean, without your back end support and without your technical expertise, master of your craft as well, from all the way from Cape Town. And yeah, the two of us, inshallah, we make a good team. I'd like to see all the learners at a point, maybe at the ICC, inshallah, very soon. From us
Okay.
here at Kway, Jazakallah so much, and you guys have been amazing.
Okay, that's it from myself and Mr. Kota. Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum. See you
When
guys.
we
See
take
you
care of
guys.
each
See you
other,
guys.
wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqaf can bless our community with a legacy of care.